Hello everyone, welcome to the Imagine Innovators 2026 live stream. We're coming at you live from Amsterdam in the Capital C building. I would love to say it's a sunny day, but it's not. We're here with Edge Impulse and we're your hosts, Adam and Brian. So let's make some introductions first. So I'm Adam, I'm from ipXchange. Who's ipXchange? Well, ipXchange is a content platform by engineers, for engineers, bringing the latest and greatest disruptive technology right to your doorstep so that design engineers, maybe like yourselves in the audience, can get yourselves into what you could be building in the next few years. Check us out. We cover a lot of content, webinars, tutorials, and we've partnered with Edge Impulse to help them cover their live Imagine Innovators event. I'm joined by Brian. Brian, who are you?
Hey everyone, I'm Brian McFadden. I'm a developer relations engineer at Edge Impulse, and I'm from Canada, but like Adam said, today we're hanging out in Amsterdam at the Capital C building. Super cool venue that we'll talk about in a little bit. And what else would you like to know, Adam?
Well, first off, what is Edge Impulse? Who do they do? What do you actually do?
Yeah, absolutely. So Edge Impulse is an end-to-end ML ops platform. So we help you with everything from data collection to data processing, feature extraction, training your model, and then bundling all this up into a deployment package that you can easily run on an edge device.
Awesome. Before I ask the next question, someone has already asked, will the contents be recorded for later viewing? Absolutely, yes, they will be. We'll be providing an on-demand recording after the end of this whole day live stream. So, Brian, tell me, what is Imagine Innovators? Why has Edge Impulse decided to host this conference? What's sort of the aim of this event?
Yeah, for sure. So we used to have a conference, and we still have it. It's called Imagine, but we wanted to make a conference that was a little bit more developer focused. So we decided to create Imagine Innovators. And this is the first time we're doing it in Europe, but it is a way to bring the developers together to have technical sessions, do breakout sessions, workshops, see some demos, but more than anything, it's a way for the developer community to connect and interact and learn from each other and form those relationships. And then beyond that, it's just a way to have a little bit of fun.
Awesome, awesome. And so we're inside the Capital C building in Amsterdam. We're in the clock tower. There's actually a lot of clocks around us. None of them currently tell the time. The time here is 10:07. We're Central European time, Central European Summer Time. So that's UTC +1. Any timestamps that are referenced in this live stream will be based on that time zone. So, Brian, let's say that for any of us in the audience who might have a chance of attending Imagine Innovators live themselves at Amsterdam, what are the kind of things we can expect?
Yeah, what you can expect, first off, I know we've already said Capital C a few times, but it is a super cool venue. So we're not hanging out in a hotel conference room. It's not dim and dark. Up on the top floor is where the main stage is, and the whole roof is domed windows, so tons of natural light, super cool spot. Beyond that, like I said, we've got the breakout rooms, so lots of different rooms to see the extra sessions. In the main hall, there's demos. You can check out some robotics. There's a humanoid robot. There's some factory line anomaly detection monitoring setups. And then there's a restaurant, a bar. Everything's kind of funky. Like we already said, take a look at this room. There's clocks everywhere. Each room had its own artist kind of create the look and feel of that room. So lots of cool different spaces and lots of things to check out beyond the tech.
Awesome. But for those of you who can't attend Imagine Innovators live, well, that's what we are here for. With this live stream, we're going to be pulling out speakers from their sessions, taking a little bit of a snapshot into what Imagine Innovators is like if you can't make it in person here. So this isn't just going to be like an information dump to you in the audience and you just sort of sit back and watch it and take it in and thumbs up. We're keeping this very interactive. So you can interact with us in YouTube chat, as some people have done already. And we're going to be having elements where we're going to be asking you questions, we're going to be asking you polls, and some of our sessions in the agenda today will be interactive. So you guys in the audience can vote on how you can actually shape and define what some of these sessions look like. So speaking of sessions, someone's already mentioned that they're here for the demos. So I think it's time we run through the agenda. So we have 12 sessions planned today in 2 3-hour blocks. So we have a morning block, which is aimed at those of you watching from Europe, and then we have an afternoon block aimed at those watching from United States. But of course, it doesn't matter. If you're watching this at 3 a.m. in America, I don't know what you're doing, but welcome, welcome. You're very welcome to join us. Likewise, for our evening, afternoon session, if you're watching from Europe or anywhere else in the world, welcome. So these 2-hour blocks, these 3-hour blocks, mind you, will be split into 2 sessions across the day. We have 10 a.m. to 1 p.m. Then Brian and I are going to have lunch for about 2 hours from 1 to 3, and then we'll resume from 3 to 6 p.m. And again, this is Central European time. However, in the middle of the lunch break, we're having a very casual, informal Q&A session with a very special guest. Now, I can't reveal to you who that guest is yet, but rumor has it they're not quite human. So I'm really excited for that one. I can tell Brian is too.
I'm pretty excited. It's going to be a lot of fun, that session.
So the main takeaway is that we're going to have action throughout the day for you to watch. Our sessions are split into 3 categories, mainly, here or thereabouts. We're going to have sessions dedicated to demos, where we're going to actually get the product or the piece of technology, we're going to put it out in front of us, and we're going to have the speaker who built that demo talk us, how did they build this? Why did they build this? Where does Edge Impulse come into the picture? And why should you care? We then have 2 roundtable fireside sessions, one in the morning and one in the afternoon. And here we're going to be tackling a particular topic area, which I'll be getting into in a second. And we're going to have 3 or 4 speakers from Edge Impulse, as well as us hosts who you might get tired of at the end of the day, talking and basically having an informal chat about some of the most prevalent topics in the industry right now. Lastly, we have informational talks, and these are very much more conversations with a speaker about a particular topic. We're going to be looking at pieces of hardware, breaking down exactly what makes some new Arduino boards so cool. We're going to be talking about some of the initiatives that Edge Impulse is doing in the industry. So overall, we have a wide gamut of sessions. So let's run through the agenda. So after our little intro that Brian and I have done, the very first session that we're going to be doing from 10:30 to 10:50 is looking at a ROS2, otherwise known as a robotic operating system, robot inspection demo. And this is going to be a cool robot that looks at pipes autonomously and figures out where are the anomalies in these pipes. We're going to do this with Mo from Edge Impulse, and we're going to have a deep dive into how he developed it, what platform is this on, what hardware is it running, and where does Edge Impulse come into the picture. Then at 11, we're going to have a fun, short chat with Jim. Jim, you're going to see plenty of him in our live stream today. This is going to be talking about some of the initiatives that Edge Impulse is doing for universities, how students are currently and in the future can make use of Edge Impulse, and what are some of the cool projects that people are building with today that they might not have been able to do in the past without Edge Impulse. Then at 11:25 to 11:50, we have a talk with Gareth from the Consult Red team about a slightly different approach to traditional machine learning called lazy learning. That's going to be very much a cool, technologically informative session for us, so I look forward to that. At 12 to 12:20, we have our first roundtable, and that's going to be with very key figures from Foundries.io and other companies. And here's the main topic for that roundtable session. The question is this: why is it so difficult to build a production edge AI system? I don't know. We're going to find out with them. And our last session of the morning is going to be from 12:35 to 1 p.m. And this is going to be what we've called prompt roulette. And this is the first of our really interactive sessions where you and the audience can directly shape how this unfolds. So this is going to be a fun interactive session with Mark, where he's going to agentically build a project with Edge Impulse and using agentic AI robots, basically going, you and the audience can vote on what those products, what the project that we're going to be building is going to be, and he's going to try and basically build it in the 20 minutes that we have here. It can work, it might only partially work, it might fail. Either way, it's going to be very exciting to watch. Then we have our intermission for lunch, but between about 1:30 to 2:30 p.m., we're going to have a live Q&A session, as I mentioned briefly earlier, with a special robotic guest. We're also going to have a Q&A session in that one with a human guest called Louis, but he's not important. We're then going to have a break, and then we're going to make start with our afternoon block at 3 p.m. So from 3 p.m. to 3:20, we're going to start with a hardware breakdown of the new, shiny Arduino Ventuno Q. We're going to be looking at a dive in all of its cool features. We're going to have one physically in front of us. We're going to talk with Leo about what makes this board so cool and perfect for your next project. At 3:35 to 4, we have Doom the video game. So Jim's coming back from the morning session to show us Doom running on the Arduino Uno Q. And he's going to tell us how at all it is relevant to Edge AI. Now, I don't know the answer to that. I guess you're just going to have to find out. At 4:15 to 4:40, we have another one of our interactive sessions, and this is called Poisoning a Model. This is one where you can directly shape as well. So you guys are going to be able to vote on how to poison a data set for an ML model. This could be a variety of ways. This could be injecting high amounts of background noise. It could be intentionally mislabeling data. Then we're going to take Carl from Edge Impulse to show us what the effect of those poisoned wells, I suppose, is on the model performance, as well as how you can use Edge Impulse to fix it. At 4:50 to 5:20, we have our second and a really exciting fireside roundtable chat with the Edge Impulse R&D team. And this is going to be talking about the history and the future of the platform, as well as any lighthearted behind-the-scenes stories and any funny tales. Although we have signed an oath not to talk about any offsites, so anything to do with Edge Impulse, and we will be taking audience Q&A, so you can ask the Edge Impulse team directly anything to your heart's content. Finally, at 5:30 to 6 p.m., we're going to have a recap and giveaway where Brian and I are going to go over some of our highlights from the day, any sessions at the actual physical Imagine Innovators event that you should recap on or we missed and we would have loved to mention today, as well as how we felt the event went overall and any funny parts that happened throughout the day. One thing I very, very briefly mentioned was giveaway. So we're going to be giving away an Arduino Uno Q to one lucky viewer of this YouTube live stream. The way you can win this is to interact with us, comment, chat, answer our polls, just basically interact with us as much as you can. At the end of the day, we're going to be announcing who that lucky winner is. Awesome. That's our whole agenda for today. Brian, which ones are you most looking forward to?
Well, I was just thinking as you're talking there, it is a jam-packed agenda. We've got lots of cool things going on. I think I'm pretty excited about the interactive ones. So if we get to play a little Doom with Jim, if we get to work on a model and training a model, Mark trying to vibe code an app building upon Edge Impulse, an Edge Impulse model, I think all that's pretty exciting. But then also, like you said, the R&D group, they've got a ton of knowledge, a ton of history, a ton of like what's going on behind the scenes. So I'm really looking forward to that one as well. And I think in summary, I'm looking forward to all of it. I think we're gonna have a lot of fun today.
Awesome, awesome. So the first question I want to answer, you guys in the audience, for those of you who've joined us, thank you very much for getting up in your morning. The topic around Imagine Innovators and Edge Impulse in general, it's in the name, Edge AI. Could you give us very quickly, for anyone who doesn't or isn't familiar with the concept of Edge AI, Brian, what is Edge AI? How does that differ from like ChatGPT?
Yeah, at a very high level, a lot of initial machine learning models were developed to run in what's called the cloud. So in big servers, you have a ton of resources. The models just get bigger and bigger. Edge is the opposite of that. So if here's the cloud, Edge is as close to the data as possible, so where you're collecting the data, and you want to run the models right there where it's being collected. So it introduces a lot more of constraints. You're restricted by your RAM, your memory, your processing speed, all sorts of things. You might not even have power. It could be battery powered. So Edge AI is all about how you run these models on these resource-constrained devices where the data is collected.
Awesome. And so I've just put in YouTube chat on the ipX YouTube live stream my first question that I want to ask you guys in the audience. And that's, which part of Edge AI are you most interested in? I see some of you guys answering already. A lot of people are very interested in, one, the hardware capabilities and selection. What actually can today's hardware or tomorrow's hardware, in the case of Ventuno Q, do with Edge AI? What are some cool things that we can actually deliver today? As well as how to actually train and deploy models. And that's perfect because that's pretty much what Edge Impulse does. So that might be why you're here. So some of the sessions to look out for today, if you're doing data collection or curation, join us for lazy learning, and as well as poisoning a model. We're going to do deep dives into data sets and everything to do with data. If you're interested in model training and deployment, come look at our roundtables about production Linux, as well as our upcoming technical session on ROS2 or ROS2. If you're interested in building into production, again, our morning roundtable session. Why is it so difficult to build a production Edge AI Linux environment? If you're more interested in the hardware capabilities, like I said, the first afternoon session is going to be a hardware breakdown of the Ventuno Q, seeing it live in front of us. And also, I would come and watch us play Doom on the Uno Q. I promise you it will be relevant to Edge AI, but you're just going to have to find out for yourself. For now, that's what we have for the intro. Coming up next is our first technical session with Mo. This is going to be, as I've mentioned, a deep dive into a ROS2 pipe inspection robot at 10:30. I'm going to see you then.
camera on the top. You have a larger view camera to look for the joints, and then you have a zoom camera to look closer to those risky areas and inspect it. So this is a platform that allows you to do that. It goes automatically, follows the pipe, checks all the joints, and then zooms in and takes a close-up picture and analyzes that. So on the onboard of this device, you have Rubik Pi that runs 2 models in parallel. We trained these 2 models in Edge Impulse. One of them is a YOLO model to detect the objects, and then the other one is a FOMO AD model to detect anomaly detection. And once it is detected, it will flag it up as an anomaly joint, and this can work days and night, and personnel can go ahead and sleep and rest.
And then you have a video of it doing its thing.
Yeah.
Maybe if the producers want to show us this video, what that looks like. Sorry, the audio cut out very momentarily during that session. You didn't miss much. It was just us doing introductions. Mo, maybe you want to reintroduce who you are, what you do at Edge Impulse.
Yeah. I'm Mo Sani, a solutions architect at Edge Impulse. I work with our customers and help them to be able to build AI-enabled products and integrate Edge Impulse into their products. Yeah.
Awesome. So in terms of the robot itself, it's built on Rubik Pi. What's Rubik Pi? What is Rubik Pi?
Rubik Pi is a developer-friendly platform based on IQ6, which is QC6490 Dragon Wing board. It has integrated MPU for running AI models, and it's quite powerful. You can bring up Ubuntu on it and run multiple models on it, and it just kind of works in low power mode.
And in terms of the main components, it's running on the Rubik Pi, and then it's using ROS2. What is ROS2, and how does that integrate
good
with Edge
question.
Impulse?
I forgot to talk about that part. ROS2 is a go-to platform or operating system when you want to build robots quickly. So it has basically all the communication layer built that is suitable for robotics. So you kind of have these nodes that they can communicate to each other in a very fast way. It's a platform agnostic. You could run it in multiple hardwares, and then it has all the ready tools for simulation, for like modeling your robots, for sending commands to your motors, and everything is ready. Now you already have a lot of examples that use ROS2 for robots, and now we have the Edge Impulse plugin that allows you to deploy a Edge Impulse model into the ROS ecosystem. So that's really helpful now. And
so let's start from, I guess, the model pipeline. You start at the beginning with data collection. Walk me through how I collect data with the robot. How does that end up going through the whole chain to actually then deploying this on ROS2?
So you would probably build a robot that you wanted, like a hardware-wise. You build it, you start attach your camera, and you kind of get it into a form that you're ready to collect some data. Then you can directly connect that, let's say if it's running on Ubuntu, Linux, any sort of Linux device or a native bare metal system, you can connect it directly to Edge Impulse and then run your robot as if it was supposed to run it eventually, as much as you can, and collect some data to the dashboard directly. And then you go through automatic labeling or any other pipelines that we have. Brian is probably able to talk about those ones. And once your data format and labels are ready, train a model, and then you can deploy it back directly to the hardware and replace that data collection software that you had with this trained model, and you're ready to go.
And so Brian, Mo really briefly mentioned from your side, how does that then link in with the Edge Impulse workflow?
Yeah, exactly. As Mo said, I know quite a bit about this pipeline, but linking in, so a few things he mentioned was the data collection. So you can actually connect directly to the Rubik Pi to bring up data directly from the board into Edge Impulse. He briefly mentioned labeling. So we have a lot of AI labeling tools to help you go through your entire data set and label things without manually drawing bounding boxes. And then something I don't think you quite touched on or didn't go into depth is the deployment. So I think you created a custom deployment block for this to integrate with ROS 2 framework, correct?
Yeah. We started the custom deployment block, but now we want to open that up and properly integrate it as a default deployment. So that's
and that's a super cool aspect is that the Edge Impulse platform is designed to be extensible. So we have like the defaults that most developers need. But if you want to do something a little bit custom, we didn't have a robotic anything in Edge Impulse at the time, but you were able to extend the platform, build the block, get what you need. And now I think since other developers are seeing this as useful, it's like, hey, let's put it in the platform.
Yeah.
And so you can build your own things. If it's useful, maybe it ends up in the platform one day. Yeah, very cool.
Nice one.
And you have some clips showing the robot actually doing it.
Yeah,
so maybe walk us through
Do you wanna
what that looks like, what that looks like in
screen?
action. I'll give Mo a second.
Yeah, that's fine. Let me know when you see the screen, yeah? Oh, you want to see it from here? Okay.
So maybe walk us through what the robot actually does,
Yeah,
step by step.
Yeah, I'm gonna. So, yeah, you can see this is actually recorded from Embedded World a couple of months ago. So this robot is following this pipeline, and it has two live views on the screen, and the bottom view is a camera has a wider angle. It looks to find joints on the pipe. So joints are the areas that we defined as a critical corrosion points, and then we run a model that is YOLO Pro on those joint detection. And once you detect the joints, you send the coordinates to the camera on the top. And that camera has a pan tilt, and it points the high resolution camera with a zoom lens to that joint. And it does an anomaly detection on the top view, you can see it. And wherever there is rust or any sort of changes, as you can see it right now, you would kind of like flag it as anomaly and store the coordinates of that, and it just goes on forever continuously, and it all runs on battery and doesn't need any internet or anything. Yeah.
So something that is really cool there is when I first started with Edge Impulse, we would only run one model at a time. But what you're talking about there is a model cascade. So now you're linking the YOLO Pro object detection, you cut out that image, and then you only do anomaly detection on that joint, correct?
That's actually one way to do it. That's very interesting, it's very common. But now I had the luxury of, I had extra processing power and extra, room to add one more camera. So now I have a zoom camera that actually zooms into that point. And so I don't have to do the cutout and use the same view. So I have another view. You have two camera views basically. One view for detecting, and then another one with a zoom lens.
Okay, and that's what you're saying. You pass the coordinates over and do. Okay. Nice.
And so one point you mentioned was that this runs basically completely offline as well.
Yeah.
Why would I care about that?
Well, that's quite important for a few reasons. One is that you might not want to send your data, your site data to the server, to the internet. That carries a lot of risks. Second one is the latency. You might not want to wait if there is a critical thing that your robot needs to detect and suddenly shut down a valve. You don't want to wait for that latency. And the other one is the cost. So every time you send a message or an image to the cloud and back, and you wait for the inference result, you're using a lot of data. You're using a lot of processing cost on the cloud, which is expensive, and you're also using a lot of power because communication costs a lot of power on your robot. Doing all these locally saves you battery life and also saves you money as well.
And one other thing on top of that is an inspection robot like this might be in a remote environment. You might not even have a connection.
Might not even have that.
Or if you do, it could be a satellite connection, which is costly as well, very slow. You can't transmit a ton of data. So you might not even have that connection to begin with.
Exactly.
And so if let's say I've deployed one of these robots into the field, what's the level of, I guess, human intervention, human interaction, or how autonomous actually is this system?
Yeah, I think that's a good question, because sometimes everyone aims for like fully autonomous,
Sure.
which I don't think is a good idea. You want to automate the boring parts and have the human be in charge for the risky area. So for this one, robot goes on and inspects the pipes and finds like risky areas. Let's say you can categorize the risk in 3 levels and say some stuff are like immediate danger, and robot directly sends a message to the whatever valve and shuts down the valve.
Right.
The second area, like let's say it says needs attention, and then that would go back to the operation room, and the human can like kind of label them or check them again. And the third one will be like, just robot can handle it automatically by itself by passing it to a VLA for labeling, let's say, or an LLM for like extracting extra information. So you could kind of think the best way is to have a hybrid model and mixing humans and LLMs and the robots all together.
Awesome. One question I want to ask for all of those watching in the audience related to this is which part of Edge AI development do you find the hardest? And while you guys in the audience answer this question, Mo, back to you. If I were, let's say I wanted to build one of these for myself, I've got some leaky pipes in my house, but they're under the floorboards. I don't really want to crawl under there. How do I get started? What sort of tools does Edge Impulse provide to help me get started with building it like this? And how can I find out more about, integrating that with ROS too?
Yeah, so we have a blog post about this. We are also launching a series. I think Owen worked on it. You might know in your team, Ryan. We're launching series about robotics, so different pieces of, let's say, mobile robots or manipulators or robot arms, all those things. So that's going to be available, but essentially it comes down to picking your hardware. So you need to find the hardware that's capable of communicating and receiving commands and reading sensors basically from your wheels, right?
Right.
That's the basic chassis. And also I have the top camera gimbal that moves the camera. Depending on your use case, you kind of have your physical setup ready. Then you grab a board that is capable of running your model. So it could be Raspberry Pis, it could be Rubik Pis or Arduino, Ventuno Qs or whatever, depending on what you want to run. Some of the models can run VLAs as well, so maybe if you want that, you want to go for like IQ8 or 9, but not if you don't need a VLA, this IQ6 is enough. And the current software that's running is actually using less than 5% of the processing power of this one. Yeah,
so you've got a lot of overhead,
room,
tons of overhead.
Yeah.
Awesome. For those of you watching at home, if you missed the little intro that Brian and I did at the start, we're going to be giving away an Arduino Uno Q at the end of today's live stream. If you want to be a part of that, enter with a chance to win. Please keep interacting in chat with our polls. Speaking of polls, before I reveal what people think is the most difficult part of Edge AI deployment, what do you think, Mo, is the most difficult part?
Good question.
Edge AI
Just
deployment?
before the giveaway, I was going to ask about the giveaway. Are we able to take one of these clocks?
I don't think the clocks are in the giveaway, but we'll see what we can do.
Ironically, I don't think any of them actually tell the current time. But
Useful.
what do you think is the most difficult part?
Difficult part of the building and in the pipeline is probably the data. Getting the right data is really hard. So we need to focus on that rather than like, let's go get the latest YOLO model or whatever.
Yeah.
I think having a right data set is really important.
Yeah, I have to agree with that. Everything comes back to data collection. Does it actually represent the problem space you're trying to solve? And it all comes back to data.
Yeah.
That's really interesting actually, because when I asked that question, most of the audience thought that model deployment and maintenance was the most difficult part. But as we were speaking, it actually changed, and now it's to collecting data. So the audience agrees with you.
Interesting.
36% of people say collecting data is the most difficult part.
Deployment can be a challenge for sure, but you have to get the data right before you even get to deployment.
Mm-hmm. So 2 questions for you, Mo. Thank you very much for you guys in the audience who've asked them. Number 1, how do you deal with data variety in harsh conditions? So for example, like a dark tunnel with pipes in it, do you collect that kind of data and train on it? Or do you use, say, more like synthetic data generation?
Very good question. Yeah, this always comes up because sometimes it's really hard to get a lot of data. And so there are multiple ways to solve this. One is obviously to try to collect a bit of real data, if not all, and mix it with synthetic data. The other one is obviously synthetic data, where you want to make it as close as possible to the real one. There are ways to do it. You can randomize it, you can add noise to it, shades, and all these like enhancement you could do to get it as, let's say they call it sim to real gap. So you want to reduce that gap, the simulation to reality.
You want to make sure it correlates basically.
Yeah,
like the synthetic data is very much as if it is real data.
Yeah, then the other one is to use models that are actually robust for this. So if you want to do anomaly detection, you actually don't need a lot of bad data. You can just train it on good pipes, which might be easy to collect rather than anomaly environment. So that's the other one. But yeah, that's I understand it's quite hard to collect real world data. Yeah.
Awesome. And then the second question is, a lot of pipes are behind walls, or maybe they go through walls into a next room or travel upstairs, for example. Obviously, this robot has, it's on wheels, but how mobile is the robot? Is it very limited to its environment?
Yeah, so this is, obviously we didn't want to solve all the problems of like pipe inspection. This was like kind of to showcase if this was a challenge for you, which was for some of our customers, how you can actually quickly build things like this. Now, if your use case is different and the pipes are, vertical or behind the walls, then your platform should be different, but the kind of the journey to get there and the pipeline is similar. Basically collect data, have your hardware collect data, train a model, deploy. So that framework should not change, but yeah, you could have it smaller form that goes into the pipe, or let's say a flying drone that flies around, different use cases you can think of. Yeah.
Awesome. Mo, thank you very much for joining us, giving us an insight into the robot that you've built. That's all for this session today. The next session that we have coming in about 10 to 15 minutes or so, we're going to be talking about the next generation of engineers, maybe more my age or even younger than me, the students who are building with Edge Impulse. So come and join us for that one.
I'm excited to
Hello and welcome back. Now we're going to have a discussion on some of the initiatives that Edge Impulse is doing for the next generation of embedded engineers, people like myself, well, maybe slightly younger than me, those at university. We're joined by Jim.
Hi everyone.
Jim is actually doing another session with us later today, which is running Doom on the Uno queue. Be sure to check that one out, but we're not talking about that right now. We're talking about universities. So Jim, first of all, what do you actually do at Edge Impulse?
So I'm a DevRel engineer like Brian here, but one of my main focuses is working with our community. So I help manage our university programs, which we're going to talk about today, and then also our expert network, where we sponsor projects in the community and kind of get people excited about Edge AI through really cool use cases.
Awesome. Jim has done plenty of stuff with ipXchange before. Webinars, we actually did one recently on Foundry's containerization of Linux and stuff. So, Jim, the title of this session, Edge Impulse and University. What is Edge Impulse doing with universities? Give us the overview.
So I think for me, one of the really important things about when I joined Edge Impulse is that I actually used Edge Impulse to do my dissertation when I was doing my engineering degree. And I thought it was a really, really useful tool for kind of quickly understanding the reality behind machine learning, which is that if you can apply machine learning to like a physical sensor, you can get it to detect things in the real world. It's a lot easier to understand than some of the more abstract theories behind like neural networks, where you might be just working on like a general data set. So I started off by detecting a particular sound in an audio stream as part of my dissertation. I found it super, super intuitive to pick up and take. So when I came to Edge Impulse as a job, I was really interested in how can we spread the use of Edge Impulse as a tool among universities for teaching people about Edge AI, but also teaching people about that kind of intersection between the physical world and the digital world. So yeah, what we do at Edge Impulse in our university program is we give away our full platform to lecturers to help them build courses and coursework around Edge AI so that students can go and build really cool stuff with our compute. We also generate courses ourselves. So we'll be talking about that a little later, but we've already got one course on Coursera, which we've had over 50,000 people take, called Introduction to Embedded ML. So there's a bunch of courseware there, and that's all open source. So lecturers can take that and go and build courses on top of it. And then the final thing is I run a thing called the Campus Ambassadors program, where we sponsor a few really exceptional students from our community on their campuses to run workshops, webinars, lectures, and hackathons to kind of spread the good word of Edge AI at the grassroots level around the world.
And so, you mentioned Edge AI. Edge AI obviously is the theme of this whole conference, the theme of Imagine Innovators. Imagine Innovators as well, very much focused on what innovation is coming down in the future. So for the students and for those in the audience who may be students, I see a few people in chat already. Someone's working on their thesis in machine learning and edge devices. Other people are doing their, currently students working on projects which might involve Edge Impulse. What does Edge AI mean specifically to those students? Like how is that going to affect what they might be learning in the next few years?
So I think everyone's really abundantly aware of the kind of impact that AI as a general topic is having on the workplace, on kind of what you're expected to learn in the future. But I think Edge AI is a really good starting point for students to start at, because it grounds you in the real world, and the models that we're talking about that you can develop in Edge Impulse, for example, are small enough that you can kind of wrap your head around them. So rather than looking at ChatGPT, which might be in the trillions of parameters in the latest model edition, like there's no way you could ever do the manual mathematics to understand what happens with even one single token generation in ChatGPT. With something like a neural network to detect a particular type of vibration in accelerometer data, you maybe could be working with 20, 30 neurons, and you could physically do the maths there. And that's actually something that we're seeing lecturers doing at universities to explain AI, is they're taking something that has like real physical tangible inputs and outputs. So a vibration signature, and then detecting whether like that means that someone is walking or standing still. And you can physically do the maths yourself there. And then that means that you can understand how these AI models are being trained. So I'm seeing Edge AI used as a real tool to kind of branch from the fundamentals that you might learn at university through to something like generative AI in the future. And then the other side of it is seeing projects. I remember being at university, one of the best things was the free time that you had, the free time to go and sort of invest in yourself and explore new technologies and new projects. So a lot of the really innovative stuff that I'm seeing from the community is coming from students who are building stuff in hackathons, who are building stuff, you know, in their free time. So there's a lot of stuff in that kind of field as well.
For those of you in the audience who are currently students or working on an Edge AI project, please tell us what your project is. If we have time, I can pitch that to Jim and Brian here. See, you know, maybe if they've got any words of advice, any pitfalls. I remember when I was at university, we did the absolute classic machine learning course, which is recognizing handwritten numbers.
Yeah.
It's like the neural network course.
NIST data set, there we go.
Exactly. So Brian, to you, when it comes to what future engineers will need to sort of learn in the future and how that is different to what they are learning now, with the theme of Edge AI and with, you know, Edge Impulse coming out as a quite intuitive platform for students to use, what are some of the things that you can see down the line that students might need to learn that they aren't currently?
Yeah, I think a couple keywords, you said it, Jim said it, is intuitive. So having these tools to be able to build something that you couldn't have done before. So someone like myself, I'm a little bit older than you guys. My university days were 20 plus years ago. So I was learning C++, PID controllers, if-else statements. I just didn't have these tools to create this type of intelligence for edge devices. It was much harder. So to answer your question more directly, what I think people need to learn is the actual tooling. So what is accessible to them to actually enable them to do something that they couldn't do before. So I think that is the main key, and I'll leave it there. But first, before we go back to you, I got a question for you, Jim.
Sure.
Because you mentioned we have programs for lecturers and campus ambassadors. How do people get involved?
Yeah, so if you're a lecturer, you can head to edgeimpulse.com/universities, and there we've got all of our course materials available there, and a form to sign up for getting access to our enterprise access for lecturers. So you can sign up there for free, and I'll go and make sure that you get that access. If you're a student, head to that same page, edgeimpulse.com/universities, and click the big link at the top which says, I'm actually a student, not a lecturer. And that'll take you over to our other page where we have the application form for Campus Ambassadors program. We're currently recruiting for next semester, so sign up now and we'll review your application. Hopefully you'll be one of the lucky ones who gets to come on board. We've had a great time this year so far with our first cohort. They've run a really big hackathon in India, run a bunch of workshops in Canada and the US, and we've even got Milan here today doing a talk. He's one of our campus ambassadors in Germany. So you can check that out later maybe. So yeah, you can get involved there. And then we've also got a newsletter sign-ups for both of those where you'll be able to see anything that we do in the future. One last thing, we also, for students, if you're doing a thesis project, have a link on that page. It's also linked on the forum where you can apply for extra compute for your thesis project. So I can grant you 120 minutes of compute per job. It genuinely is.
Personally, Jim.
It's my hands that do the job.
So my question there, Jim, if you personally are granting it, where's mine?
Well, are you a student, and do you have a student email address? Because that's the one thing I have to see.
I have an alumni email address.
I'm not. I plead the fifth on that one. But yeah, you have to have an educational email address, and if I see that on your application, then I'll be able to grant your projects 120 minutes of compute. So hopefully that's helpful for your thesis, and it gets you over that hump if you're training like a vision project for the Edge.
And so you mentioned Milan is here. Milan is one of your student ambassadors. Do you know what his talk is on this afternoon?
I can't off the top of my head remember it because I'm prepping in my head for my talk, which is very soon. So it's lost on me, but maybe Brian can look it up while we're talking.
I was going to say, I might have to pull
that
this
talk,
up.
That talk that you have very soon, that's on Doom, isn't it?
That talk is going to be on Doom, and we're going to be exploring the extensibility of the Edge Impulse platform, so building custom blocks for synthetic data using Doom, and then deploying a model that's an aimbot trained in
Oh,
Edge
so you're
Impulse.
cheating.
To
Oh,
cheat
but it's in Doom.
with Doom.
Right.
So we're going to be
Exciting.
teaching you all how to cheat.
And that's going to be going on
esports.
this afternoon in our afternoon block, so make sure you come around for that. So while Brian looks up what Talk Milan's doing, Jim, what do you find at the minute that students can build now with Edge Impulse that perhaps they wouldn't be able to a few years ago? What are some parts that they're really sort of picking up on, and what are maybe some parts that are a bit more obscure at the minute?
So I think a lot of students will be picking up Edge Impulse to build vision projects. Things like object detection, classification are classics. But actually, the place I'm seeing a lot of interest from students is on the microcontroller side.
Right.
We're seeing embedded engineers or trainee embedded engineers coming in and going, oh, you know, I'm learning about these microcontrollers, but actually, how do I bring AI into that world? Edge Impulse is this really useful tool that can help me kind of build some AI into a project that might be going raw MCU. So sensor data, so you're seeing some really innovative stuff there in the world, yeah.
And so what kind of, are there any fun projects that, I mean, if you, as it seems to be, are the omniscient overseer of Edge Impulse Compute, are there any fun, you know, I'm sure because people name their projects many different things.
Yeah.
What are some really fun projects that you've seen?
I've seen a couple of really cool projects in Africa looking at tracking wildlife using sensor data, and I always love seeing that kind of stuff. My girlfriend works in wildlife conservation, so we always are really interested to see what's coming out in that field. Things like bird detection, things like, you know, elephant tracking. I love those sorts of projects.
And then one project that someone in the audience has mentioned is detecting whether people are sedentary, sitting or standing. So a lot of different ideas. If I want to build a project myself, and let's say I go to Edge Impulse's website, what are the things that Edge Impulse allows me to do immediately as a student?
Yeah, so as a student, you can sign up for free, just for a free account, and you get access to the full platform. You can collect data from your phone or your laptop to start building models with, and we can help you build models for sensor data, for audio and for images. And then once you deploy, you can deploy down back to your laptop or your phone, or to a microcontroller. We have an Arduino library that's really popular with students because that's often a platform that they're using in their studies already. So you can deploy your model straight to Arduino. And then we have those courses available as well that are really useful for training yourself up on some of the basics of this technology.
Brian, it looks like you've completed your research. What talk is Milan doing later?
I completed my difficult research. So the title of the talk is Designing Robust Sensor Fusion Architectures for Real-World Edge AI. And the idea is that if you're fusing different sensor modalities, you can have additional complexities. So how do you do that sensor fusion but maintain your power latency and your inference latency and your memory constraints?
Wow, awesome.
Yeah.
That's one of the things I've been really impressed by with the campus ambassadors that we brought on this year, is that they've gone from kind of not having too much public speaking experience to being enabled to do a really complex technical talk, and their confidence levels are just going through the roof. So that's one of the things that I always say to students at university. If you can take those opportunities to go and speak about the technical topic that you're interested in, then you're going to learn a huge amount about like those soft skills as well as the technical skills. And Edge AI is a great field because not many people actually really know about it. So if you can train yourself up a bit, you can have something that will teach people something new.
And so sort of the main takeaway that I'm getting is that as we transition to the future, Edge AI is going to be something that's going to be embedded in like almost every single project. I mean, we joke about smart fridges, but there might be a use case there where AI is going to be used in every single offline device. And so as a student, if you can get a chance to get stuck in with it right now, that's going to benefit you so much for all engineering projects in the future. Jim, and obviously Brian, although he's staying with us, thank you very much for giving us a little chat, little overview. We're going to see you again when you come and we play Doom together.
Yeah,
we'll make sure it's relevant to Edge AI. But otherwise, you can come and watch us try and fail to play Doom while explaining why it's relevant to Edge AI. Jim, thank you very much. Our next session is going to be a unique and slightly different approach to machine learning training called lazy learning with Gareth from the Consult Red team. I'm excited to find out what that actually is about because I don't know what lazy learning means either. I'll see you then.
I'm excited to announce our new specialization of 3 courses on Coursera that will be launching soon.
on Edge AI for Linux devices. We've brought on board Robert Gallup, a brilliant educator, to design and lead these courses, and I'm going to introduce him now so that he can take you through what you'll learn.
Artificial intelligence, or AI, permeates almost every aspect of life.
I'm excited to announce our new specialization of 3 courses on Coursera that will be launching soon on Edge AI for Linux devices. We've brought on board Robert Gallup, a brilliant educator, to design and lead these courses, and I'm going to introduce him now so that he can take you through what you'll learn.
Artificial intelligence, or AI, permeates almost every aspect of life. Smartphones, smart wearables, and conversational chatbots are daily partners. Initially, AI required powerful data centers, but bandwidth, scale, and privacy are among the inherent challenges and risks to centralized computing. Fortunately, fast, efficient hardware and optimized methods increasingly allow intelligent behavior from embedded or edge devices interacting directly with the physical world. Self-driving cars, health monitors, industrial control, crop management, and wildlife conservation are just some of the many applications of artificial intelligence on the edge. Welcome to the specialization Edge AI on Linux. Its 3 courses focus on Edge AI applications using devices running the Linux operating system. The courses primarily consist of presentations from me and others, demonstrations, and hands-on projects. In this first course, you'll learn basic concepts of artificial intelligence on the edge. You'll set up a working environment using Edge Impulse and a development board, and you'll work with AI models as the foundation for creating intelligent applications. In course number 2, you'll focus on building prototypes. After a quick introduction to the Python programming language, you'll learn how to set up your software development environment and combine models and algorithms to explore application ideas. In course number 3, you'll learn about developing Edge AI products from idea to prototype and production. In the final capstone project, you'll conceive and prototype your own intelligent application. My name is Robert Gallup, and I'm pleased to be leading the specialization. As a technologist, product designer, and educator, I've worked with embedded devices for years. I've seen firsthand the evolution of powerful edge intelligence and its many uses. I hope you're excited about the possibilities of Edge AI, and that you enjoy your journey learning how to imagine and develop your own product ideas.
We're joined by Gareth from the Consult Red team. Great to have you here.
Hi, good to be here.
Every session we've done so far up to this point has been with Edge Impulse folks, but you're not with Edge Impulse, you're with Consult Red. Could you tell us, very quickly, what is Consult Red? What do you do?
Okay, so we're a UK-based embedded hardware and software design consultancy. We work across a large number of spaces. I think the business originally developed in the media space, so we do a lot of work with big operators such as Comcast and Sky. We do a lot of development of embedded consumer equipment, but we have a broader space than that, and the work we've been doing with Edge Impulse has been more around fields such as industrial, which is kind of where I'm talking today about that sort of area.
And so what do you do yourself at
Myself, I'm a
Consult Red?
solution architect, so I
Right.
tend to be working at the customer end of things, looking at sort of customer requirements. And again, that can be in quite a range of spaces, from media, industrial, to things like data collection, or it can be pure consultancy around technology choices, that sort of thing.
And so the topic of this little talk that we're doing is lazy learning. So could you give us like a very high level overview? I don't know what lazy learning is, neither does Brian.
I'll admit, I don't know it either. It's the first time I heard
what's
the
lazy
term.
learning?
So.
Well, I've kind of stolen the term. There is a sort of well-known definition of the term in ML, which is K nearest neighbor. You basically do the computation at the end when you're doing the query. I've kind of pinched it because it was quite a nice term. What I'm talking about really is, if you've got a problem, and we're talking about visual inspection in this case, if you've got a problem where you're trying to solve it using AI and you want to push that to the lowest possible hardware, so you want to minimize the actual model that you're using, then what you try and do is you try and use the information you have in the system to basically, A, remove things the model needs to learn, but also to drive the training purpose. So the overall goal is to simplify, A, the data collection process by using information you already have, and also the inference process by minimizing what you're actually trying to learn. And kind of why this is important in the industrial space, so again, we're talking about industrial inspection, and the example I'm using is a control cabinet. I don't know if you've seen them, big boxes full of various components, relays, PLCs, etc. Looking at those, trying to do analysis of those, where it's important is these products are not like basically doing defect detection on, say, bottles going through a production system, or pharmaceuticals going through, where you've got millions and millions of items all identical. These systems tend to be more bespoke, so it's kind of high mix manufacturing. You've got multiple variants and small runs, which means now your whole training process becomes significant. It's not amortized over 1 million units, it's over a smaller run. So it's basically, what I'm looking at is a collection of techniques which makes that training process more automated, and the models smaller so they can be deployed quicker and on the edge.
So a couple of things, if you don't mind, Adam. So when you were first speaking there, it sounded like what you're doing is, based on your knowledge of the system, you try to constrain the problem as much as possible so that there is less complexity to learn. Correct. Okay, and then a little bit of a fun fact, you talked about control boxes. My first job out of university was a systems integrator. So I built a lot of those control boxes and the DIN rails, putting all the relays on, wiring things up. So that was a great example for me. I know exactly what you're talking about. So very cool, and would love to learn more.
And I'm sure you realize from having worked on those, it's a very manual process. And if it's a manual process, there's a chance of errors creeping through. But if you think about these things controlling a larger piece of equipment, a fault is quite an expensive fault. So it's important that you can test them. But again, it's a trickier problem because shorter runs and more specialized variants.
Yeah, and speaking on specialization, so not only was I working on control boxes, but it was for the underwater industry. So everything had to be extremely reliable. Vibration was a big concern. And exactly what you said, it was very manual. I wired up everything by hand, one box at a time.
And so when it comes to this approach of training, is this something that can be applied to a variety of models or very particular models? So what, in your case, what models have you used yourself?
Okay,
for
so
example, to apply lazy
I
learning to?
can't dig into too much detail, but we okay, so I think let me just kind of walk through a simple sort of walkthrough of it. So one of the principles we use is, if you imagine that wiring cabinet is a box full of components, various components placed. They're placed in a specific place, so there's a design, somebody follows and places the components, so you know where they all are. And this is what I'm saying about using the information you have. You know where they all are. So what we basically do is we look at that cabinet, we use the information we know about the cabinet for the placement, and we use a foundation model, not one that we pre-trained, a zero-shot model to find components. It doesn't know what component it is, but it knows it's a component.
Would that be like YOLO or
no,
else?
these are bigger models, bigger
Right,
foundation
okay,
models, yeah. So open vocabulary models. So you can get a list of basically detections of, you know, there's something there. So what we then do is we map that against the design information we have, and we can use that detection labeled from the design information to create a labeled training set. And we're working with Universal Robots. We're using a cobot to move, so we have fixed camera points. We collect all those images, we do that labeling process, and then we go to Edge Impulse and we train a YOLO Pro model. Now, what that means is when we pull that YOLO Pro model back, we have something that, okay, originally we knew there's something there. Now we know if we run the YOLO Pro model, it says this class of components is there. So effectively, we can take that as our training set. And then because we've got a cobot, when we come to another cabinet, we repeat the process, but this time we run the YOLO Pro model, not the foundation model. So it's quick, fast, can be run on the edge. And we get a set of results there. We can compare that to our training set, and any mismatches we can then report as, well, this component wasn't missing, or this component was swapped with that component.
And so when it comes then to, I guess, the original training data set, right, when you're training the foundational model, does that then need to be different to if I was, you know, training directly with like the actual YOLO deployed model, or what does the data set look like?
Well, it's more the labeling. So say
Sure.
you were ignoring the first part that we've done and you just wanted to, you took a load of images of that cabinet. Somebody's got to sit down and draw those boxes, look up in the sheet what component it is.
Takes a lot of
add
time.
That. It's just a tedious process.
Yes.
And this is what I say, that might be fine if you're going to make 10 million of those cabinets, but you're not. If you're going to make 10, 100, it just becomes a problem, and it's not something that really is productive. It's interesting in that there's another element which is actually important to this. So say, for instance, this is in terms of how it generalizes. Say, for instance, you're looking at that cabinet. When you have built it and you look at it, you can see everything there, which means you can do that mapping process. If you're building something where you may be occluding things as you're adding things, this process can't work. So it works in classes of problems where the whole of the system is visible at a point in time where it's convenient to go through that process, capture those images, and also repeat that for test.
You go, Brian.
So I was going to say, so what inspired you to start looking at these different techniques? I'm assuming customers came to you with a specific
so
problem.
we're a consulting company.
Help us
people
figure this out.
come with problems,
Yeah.
and we see certain problems crop up again and again. So that was one of the things. We started looking at a number of cases, and this one was interesting because of the very issue. It's something where automated testing would be really important, and people want it, but it's kind of breaks the traditional sort of model for that. And also one of the things we did come across again and again when people are adopting systems is if the training of that system is a burden,
They don't do
right, you free up somebody from testing it and you employ somebody to run the automated testing, and it kind of, the economics don't always work. So it was kind of looking at how we could kind of solve those sort of problems that really sort of triggered this.
Yeah. And so compared to like more conventional model training, what type of environments do you think, or do you find that lazy learning performs best? What environments does it maybe not perform as good in?
Well, this is quite new for us, so we're just sort of starting to explore the space. But if you think about it, if the main requirements are something that's high mix, so and this could be aerospace, it could be military, it could be a large number of sort of mechanical systems. Those are all very heavy spec driven. There's a design to start with, and even if you're making a lot of variants, that design process is carefully controlled, so you have that information. So in all those systems, and then you come, and then beyond that, really, it's the constraint I mentioned, which is visibility. When you're building this thing, do you have points in the workflow where there's enough visibility that it makes sense to do a large capture and capture a large proportion of the design, and that isn't always the case. And we're still sort of exploring. We're trying to work this particular scenario through fully. It's deployment and production with customers, and on the learnings from that, we can start to sort of build out into other areas.
Awesome. One question I've just got is this sort of technique, is that open source? Is that
well, it's just a technique.
It's just a technique,
an approach,
right? It's just
really, yeah. I mean, it's just we're kind of helping people out in terms of giving them, look, here's an idea as to how to approach these problems, because they have different characteristics to maybe traditional problems that people encounter.
It did sound like there was a little secret sauce there, though. You mix in a little something extra.
Best will in the world when you approach these things, there's always sort of little niggles. So this approach works. There's a little wrangling with the foundation models to get them to be reliable. And really the challenge is turning it from theory into a practical, reliable solution. Because again, one thing I mentioned in the talk is, with all these things, when you're using AI, you're down to probability. When you're talking about verification of a system, you don't want probability, you want certainty. So there's a question as to how far can you rely on the process, and when do you fall back to a human operator to validate it, which is an important part of the process.
That's an interesting comment, because that has come up a couple of times already, and it was in Mo's talk earlier today, was at what point do you involve a human versus having autonomous decisions just based on models? So always something to consider there.
Yeah, I think you're always setting yourself up for a fall if you're saying I'm going to have a push-button, fully automated solution. And there's no need, because if you think about it, what you're trying to do is you're trying to reduce the overall effort involved in testing something. It doesn't matter if there's a small 10-minute window, particularly if you have all the data and you can present the things you want the operator to check in a convenient way. Here's what I expect, here's what I've got, here's all the information, you make the decision. Then it's sort of, rather than saying you go sort it out, you're presenting it in a way that it makes it easy for them to look at and draw a quick conclusion. So again, you keep the process quick and efficient.
Absolutely.
And so, Gareth, if I'd want to maybe integrate this technique myself on, say, like a Factory 4 project that I'm working on myself, where can I look next? What are some materials I can find?
I'm not sure.
Call Consult Red.
Call Consult Red. That's
call us up and help us out.
Happy to talk through.
Awesome. Gareth, thank you very much for giving us a little bit of an insight. If you could wrap all of everything that we've talked about into like a really dumbed down sentence of exactly what lazy learning is, so our audience can take it away and think about it, what would you say that would be?
I think only learn what you need to learn.
Right.
Don't try and learn everything.
Awesome. Gareth.
So I was going to say, I have one last question for you. So since you've been to Imagine Innovators, I first met you at Imagine.
Yeah.
How do the conferences compare? What's the feel here? How do you like the venue?
Well, first of all, I live in Manchester, so it's a damn sight easier to get to,
Yeah.
so that was convenient. I think the feel of it, the US one had a sort of higher level feel. It was more sort of strategy. Here, what I'm seeing as I come here and look at the papers, it's more nuts and bolts. It's sort of getting down into the details of things. Again, the keynote speech in both were great. It's good to get an overview of where things are going with Edge Impulse. It's always good to see sort of the direction you're going in. and you've already answered some of the things I was maybe looking for in the future with Edge Impulse.
Perfect.
So I think this is kind of definitely more sort of hands-on, and there's a couple of papers here that I'm going to get useful insights from.
I'm glad that's your feeling as well, because that's the idea. It's for developers. Let's get hands-on. Let's get down to the nuts and bolts, like you said.
Brilliant. Awesome. Gareth, thank you very much for joining us.
Thank you.
Next up, we have our first roundtable session of the day. It's very exciting. We're going to have 3 or 4 speakers from foundries and other companies. And the question is simple. Why, in 2026, is it still so difficult to build a production Linux Edge AI product? And is it actually still difficult? That's what we're going to be finding out. Tune in for that. Hello everyone and welcome back. I hope you've enjoyed the short 15-20 minute break. We're now going to dive into our first roundtable session of today. To give you a little bit of overview of what a roundtable is, we're basically going to have a chat with three of our lovely guests today around a central topic. It's going to be informal, it's going to be fun, and the central topic for this roundtable discussion is why in 2026 is it still so difficult to build a production Linux Edge AI device, or is it still very difficult? I'm joined by George, Ian and Owen from Foundries and Edge Impulse. George, if I could start with you, what does Foundries IO actually do and what's your role at Foundries?
So I lead the Foundries team, which is now part of the Qualcomm team that Edge Impulse and Arduino are also members of. What we do at Foundries is we help customers and partners go from development to production. It's relatively easy, and we can talk about this in a few minutes, to actually create a prototype and create a proof of concept and do exciting things with AI today. And then the rubber hits the road when you move to production. And if you don't do the right things in development, it can significantly delay product delivery and putting devices into the field. So we focus on that piece and help customers and partners get from successful development to production.
And in that Foundries, what's your role?
And I lead the Foundries team, so I have two main areas underneath me. One is building support for Qualcomm SoCs in open source. So this means upstreaming support for the kernel and devices in the kernel.org. And the second piece is the product side of enabling customers to have tools to navigate the increasingly complex world of taking products into production, particularly with things like the European CRA coming into place.
Awesome. And then, Ian, over to you. We obviously know at this point what Edge Impulse does, but what is your specific role at Edge Impulse?
My role is I'm leading the embedded team.
Okay.
So basically what we there do is enable embedded devices with machine learning superpowers. And it starts with tiny MCUs, Cortex M0s, all the way up to beefy machines that include GPUs, MPUs, and whatnot. So there we focus not only to run the models on device, but to run it in the most optimal form. And that takes a lot of sort of development to make that flow, really gentle and easy to follow for our users. But that's our main task.
And then last but very much not least, we have Owen. What do you do at Edge Impulse?
I am Owen from Edge Impulse, and I work in the developer relations team, creating documentation, blogs and tutorials for our users, answering questions on our forum, and just helping people to create their own models and use our tools effectively. And
so you're on the DevRel team, so I assume you and Brian work together quite a lot.
We spend a fair bit of time together, yeah, absolutely.
Yeah, we kind of cut it up between embedded and ML typically, and I work quite closely then with the embedded team. Yeah.
Awesome. So I'll start with you, George, if you want to do like a daisy chain of the microphone. Let's set the context. So when an embedded team, prototypes on whatever platform, it could be Arduino, and then they would like to then move into something that is going into production, what are some of the common pitfalls, common hurdles that they experience?
So I think the biggest issue is when you're building your own hardware and your own product, whether you're taking an off-the-shelf chip or SOM or system on module or EVK, and then you're building your own baseboard, you're building your own hardware. It's making sure that hardware is well supported upstream in Linux. If you don't do that, then updating devices becomes potentially very difficult, and this can cause significant delays. The industry numbers for failures in bringing IoT products to market is huge. I mean, it's 70% plus projects don't get to production. And the reason is because it's not that last stage. It's not actually going into production. It's about the decisions you made during development. So there's a lot of things to take account of when you're developing products around what components are you using, what software are you using, how do you update that software in the field after you've shipped the product, how do you manage devices and fleets, and increasingly how do you deal with legislative requirements around security.
And so just focusing on that point about fleet management, updating once it's deployed, why is that so important? Why can't I just build a device, ship it, and then never think about it again?
Well, that's what we used to do, right? Life was easy. Nothing was connected to anything, and you could test all requirements of the product and then never have to touch it again, get on with the next one. But the world has changed. We're now connecting everything to everything, and there are vulnerabilities that you can't design perfect software. Even if you can design perfect software, you don't know what the underlying hardware capabilities or bugs or problems are. And so things like Spectre and Meltdown in the last decade, that required significant updates of software to most devices out there. And so the world has moved into a situation where it is now legally required, or will be from next year, that you can update your devices. Depending on the kind of device you have, you can either do that over the air, or you can do it with a truck roll, or you have to be able to, if necessary, update them by completely reflashing them. But this is no longer optional. It's now required.
Awesome. And then, Ian, over to you. From Edge Impulse's side, but maybe also speaking more broadly, in terms of the tools and the software platforms that have to be in place to allow a team to take all of those constraints in mind and actually build a device that's both capable but also secure when deployed, what are some things that teams need to put in place, and how is Edge Impulse helping them?
Yes, sort of what we found by supporting all the different types of hardware. Take Qualcomm, for instance, right? They have these devices with hexagon MPUs that are really sort of optimized the model on device, but these are tightly coupled, right? So the model itself and the code running on the MPU. We found that building your model and running it on your desk works fine, but in the field, you want to be able to also to manage sort of not only the model, but also sort of the underlying code that actually talks to the MPU, right? So that's sort of the pitfalls you can come across, like in this area. And sort of the stuff that we've been working on, for instance, is closely with the Foundries team actually, is to create a Docker container that allows also not only to embed the model, but also the underlying code that talks to the MPU. That's sort of, in that case, what you test on device on your desk is the same package you can ship to your device, and you know for sure, right, that everything is aligned.
It's very interesting, actually. You mentioned that you're working with Foundries to make a container to almost have, not one click, but to do all this all streamlining, because we actually did a webinar on that at ipXchange with Jim and with Raul from Foundries. So if you want to find out more about that, please check it out. Otherwise, so in terms of the types of, because you're leading the embedded side at Edge Impulse, when maybe teams or people in the community come to you, what are some of the difficulties that are most highlighted when actually then building something in production versus, say, building a prototype?
Yeah, well, the other thing, and I think that's sort of what George highlighted as well, right? There's not only one device out there. You could have sort of a fleet containing sort of different hardware, different image sensors, for instance, right? And there you could already see what we call sort of degradation of the model, or sort of disparity of the model, where you're getting different results from the devices in the field than what you have seen on your desk. And that's something that you want to account for and want to be able to monitor and to fix, basically. Things we do there is we've rolled out model monitoring. It's sort of a look back from devices in the field that can report back sort of inconsistencies that they've seen to sort of Edge Impulse Studio, and it allows again sort of to retrain and update your model if necessary. Could also be a hardware thing, then you have to fix it, but you have sort of deep insight on what's actually happening on the factory floor.
Awesome. And then Owen, over to you. Maybe more on the developer relations side. What are you guys doing to support the community when it comes to actually building something more substantial in production? What are some feedback points that you've gotten back from the community?
Yeah, thanks. That's a great question. We had, for a long time, a very thin story when it came to ML ops and lifecycle management. And we were constantly being asked about how to integrate and show these examples with IoT partners. And we'd build documentation, tutorials, and answer questions on the forum around this. But now that we've got a fully integrated and official partnership, now that we're part of Qualcomm together, it's much easier to give answers to those stories, and we're getting much more solid examples rather than thinner tutorials, I guess. So yeah, coming back to what your question was, it's really given these examples for hardware and for integrations that we saw a lot from the customers. Community.
Thanks, Owen. I have a question to ask you guys in the audience before we continue, and that is, what is the biggest hurdle do you face when you're building a production Edge AI device? We have a couple multiple choice answers. Is it security? Is it the actual fleet management? Maybe it's the hardware. Maybe it's compliancy requirements. So over to you, Brian. You look like you're ready to speak.
I've got a question. I'm ready to jump
go.
in. So, like, great timing with the poll. I'm listening to you guys speak, and I'm a developer relations engineer, so I build a lot of demos. Like, building demos is completely different than going to production. The three of you have talked about pitfalls and things that people can come across in the development stage before you even get to production. How would someone like me become aware of what those pitfalls are? Because I don't know what all those pitfalls are. Do I reach out to Edge Impulse? Do I talk to foundries? Do I Google? Do I go ChatGPT? How do I educate myself? Because it's one of those situations where it's like, I don't know what I don't know yet until I get there, and I'm like, oh, well, now I'm...
There is information out there, right? So ChatGPT, Claude, they'll give you answers if you ask the right questions, which is always the challenge with AI. But having said that, it's not rocket science. It's just, as you say, fundamentally not knowing what you don't know. And the couple of the biggest things are in the world of open source and Linux and using Linux and Zephyr for microcontrollers, when you are using hardware that's not part of an existing reference design, so if you buy an Arduino product, for example, or an EVK from a vendor, that is fully supported in that vendor's software, right, in the BSP for Linux. But if you then start modifying and using different components, the key thing is to make sure they are already supported upstream in Linux, in kernel.org, because then they will be maintained over the lifetime of the product. And once, if you don't do that, you open yourself up to a world of pain, because you may not be able to get that software updated because the vendor may no longer create the component, they may no longer support it, they may have closed software that they're not interested in changing. So that's the number one thing we suggest that people do. And then I think to your earlier point of containerization, the good thing about containerizing your software and services and applications is that they're then portable. And not only that, they're also relatively easy to update because they're self-contained. And the nice thing about updating containers is with the appropriate orchestration mechanism, whether it's what we use, which is Docker Compose, or whether you're using something more enterprise-oriented in a bigger installation like Kubernetes, the nice thing is you can update those services and applications and indeed update models as you need to, by simply updating the container, no rebooting of the operating system, you're not rewriting the operating system code, you're basically just updating the application. So it's the equivalent almost, as I like to say, of the App Store of mobile phones, right? You can update your application, right? The difference with a mobile phone is that the end user is in charge of the update. Whereas in an embedded device, it's the fleet owner, it's that's responsible, or the supplier that's responsible for doing that update on the fleet. So that means that you need a platform that is suitable for managed devices, and so that's how that works.
So you've mentioned sort of the platform. we have obviously Foundries and Edge Impulse and then Arduino who aren't with us here, but Qualcomm are basically building this ecosystem where you can use all of these partners to go all the way from prototyping to production. What does that story look like? How can you use each individual partner?
I think Arduino is clearly the place. They have a huge developer ecosystem. They have education products, and they have been the world leader in introducing people to technology. And so I think the big benefit of seeing Arduino now building and developing with Qualcomm products as well as with their existing microcontroller products, they're continuing to do that. We now have a source of hardware that costs from $50 upwards that can be used for actually running real AI workloads and experimenting and building prototypes. So that's really exciting. And then how do we move that into production environments? Well, the Arduino products themselves are powerful, but then people use the system non-modules, SMARC modules, modules from third-party partners to build their own hardware for their own application, whether it's robotics, industrial control, whatever it is. And again, there, use hardware that is supported upstream. That's the one takeaway I would say. You really need to do that because it will make your life a lot easier as you go into production. And then we have to deal with the security issues, but we'll cover that later, I suspect.
And so one thing that we haven't touched upon yet that you alluded to sort of near the start was security regulations like the CRA. And actually it's very interesting because the results from our poll, what the biggest hurdle people face when building production devices is actually compliancy requirements. So let's touch on the CRA, not the Canadian Revenue Agency. What is the CRA? How does that affect particularly small teams?
Yeah, so the European Cyber Resilience Act, CRA, its provisions start to come into effect September of this year. And it's all about ensuring that devices can be protected against security incidents or critical vulnerabilities, as they're called, CVEs, critical vulnerability exploits. So what the Act requires is that if you are shipping a product into the EU, you must follow certain security requirements. You have to design it with security in mind. You have to have secure boot. You have to be able to reset the device to factory. You have to give users the ability to take updates onto the device. And you have to support those updates for 5 to 10 years, depending on your use case. So it imposes a significant burden on the company delivering the product into the European marketplace. And you're going to see similar legislation coming out of the US and China. So meeting the CRA requires certain things. It requires you, when you are building software, to have a software bill of materials, an SBOM, and to monitor that for critical vulnerabilities against databases that are available globally. You also have not only the technical requirements for doing updates and making those updates available to customers for years, but you also have process requirements in terms of reporting and monitoring and auditing, so that if there is a vulnerability on your product, you have to report it to the EU, the relevant EU authorities. So you need that process in place. And there are companies who can help you with this. What we're doing in the Qualcomm world is we're helping customers with tools to help them be compliant, so enabling builds of software for your product that are immutable, so they're auditable in the future, and that every time you update, you create a new immutable build and create SBOMs for every build that you make, and so on. But ultimately, the responsibility is with the company that delivers the product into the EU. And then, of course, there's this network of supply chain behind that that's responsible for helping as well. So it's a new world, and it poses a significant burden on product makers, but it's one where everybody's in the same boat, and the goal here is to make the world safer as we move forward, because historically you haven't had to do this. Now you do. And from December 2027, so December next year. Any new product has to be compliant to the Act. From September this year, you have to report vulnerabilities to the EU that are exploited, even if they're on existing products. So there's a burden that's already coming into place this year.
Awesome. Thank you. So if I could get just one very short key takeaway from all of you, what's one thing that teams need to consider immediately when they're then building? If they're going to build, let's say they've got a project that they're building that's going to come out in a year or so, what's the biggest thing that they should consider?
When you're building a development prototype, life is relatively straightforward. There's great tools from Edge Impulse, from Qualcomm, from third-party suppliers for building applications and services. What I would say is make sure those applications and services, if you're building a Linux device, are containerized and you're not using the core OS, keep those separate. In terms of security, I think you need to be aware of the CRA. You also, the one thing that I would ask is that if you have custom hardware or you're buying hardware from a supplier, please make sure it's supported upstream in Linux, in kernel.org, because that will make your life a lot easier as you go into production. But there are plenty of sources to find out more about the CRA
Awesome.
online.
And then, Aaron, from your side, what would you say is a key takeaway?
Yeah, it was a key takeaway, like for when you develop your model, especially for industrial applications, the majority of sort of the actual applications aren't finished when you deploy your first model, right? And you're always getting back like the stuff I mentioned due to model degradation and such. So the key thing is that you have these things in place, like Foundries is delivering, and with Qualcomm Docker and Docker containers, you'll be able to upload models and will improve your application over time.
Awesome. And finally, to you, Owen, from the DevRel side, what would you say is the key thing that your community needs to make sure they're aware of when it comes to security and production?
For security and production. So I guess security and production. I guess for creating a product, you don't want to hard code anything sensitive onto it. Don't leave it accessible. So if it's a embedded device or a Linux device, just be very careful with what you put there, because it's very easy to put anything on there now with agentic AI and vibe coding. It's just be very careful what you put on your...
Make sure you review everything, all the outputs.
Yeah.
And it's very interesting that you mentioned agentic AI. That's the topic of our next session. Before we get to that, I want to thank George, Ian, and Owen for joining us for our first roundtable session of the day. To answer the original question, why is it so difficult to build a production Edge AI Linux device? The answer is maybe it's not so difficult if you get stuck in with the Foundries, Edge Impulse, Arduino, Qualcomm ecosystem. So thank you everyone for joining us. Our next session, as Owen unintentionally alluded to, it's going to be a fun one. We're going to bring Mark in from Edge Impulse to vibe code a working, well, hopefully working, agentic AI demo right in front of us live for you to watch. You in the audience can influence what he's going to be making. So I'm really looking forward to that. I think Brian is as well.
I'm pretty excited about this one.
And then we'll see you back in about 10 to 15 minutes. See you then. to a very exciting session. This is one of our most interactive sessions that we're running today. We're joined by Mark. Mark, what do you do at Edge Impulse?
Yeah, thanks for inviting me. I'm Mark Pose. I'm based in Barcelona and Debrel at Edge Impulse, and I basically do all type of examples with Arduino Uno Q and Arduino devices, or Linux devices with Edge Impulse. So running Edge Impulse AI models on Linux devices.
Awesome. And so what are we doing today?
So today, actually something that happened to me since December last year is that I start writing code, and some of the sports that I'm doing now, it's basically editing AI, code generated by AI. So maybe a session that we can do now, we can vibe code an application for Arduino Uno Q if you want.
No pressure. So
A little bit of pressure.
we're going to let you guys in the audience decide what Mark should vibe code today. We've got several options for you. Either he can vibe code a rock, paper, scissors demo, insult sword fighting. Maybe Brian, you want to expand on what that means?
I think Mark needs to expand because it's from a video game from back in the day, but
Come on, it's one of the most famous graphical adventures video game from the 90s, The Secret of Monkey Island. You don't know that?
It looked
Come
familiar.
on.
It looked familiar when you showed it to me.
Please
but
say something in the chat if you play to the
yeah,
the Secret of
Monkey Island from the 90s. But it sounded like a really cool application to build, and I saw a little preview of it before, so I'm excited about that one. I hope we get to build that.
So just to give a little bit of sneak peek.
Someone said Monkey Island in chat, by the way, just for your reference.
Yes. So basically, there is one part of this graphical adventure where the guy of Monkey Island basically needs to fight with a sword master, and the sword master basically fights just insulting you, and you need to just come back with the right insult. Yeah. So we can vibe code an application with a kind of Monkey Island style with insults.
Yeah, I think that'd be very cool. But what's option number 3?
Rubber Duck Oracle. What is that?
Okay, so yeah, he's passing it to me because this was an idea that I came up with. We have all sorts of rubber ducks around, and any software developer knows rubber duck debugging. So I was like, can we play on this? Because Mark's done an app before, which was like an all-knowing oracle. So we're doing the rubber duck oracle, answering your software debugging questions.
Maybe we can ask to the audience who is doing rubber duck debugging.
Debugging.
Anyone?
Awesome. Yeah. So I'm going to end the poll now. There's a tie.
No way.
There's a tie, so I think we're going to have to take our pick.
Rock,
It's
paper,
between
scissors for the
between rock, paper, scissors.
Now, which is the result at the moment?
And insult sword fighting. So I think maybe
I'm going to be the
fighting.
tiebreaker. We're doing insult sword fighting
Awesome.
then. Yeah.
Yes?
Mark,
Yes.
Should we do that?
do you want to take it away?
Let's do it.
Yeah, let's try it. Yeah. So what we are going to do here, I'm going to use cloud code here. Yeah, let me explain. Let me give. Yeah, or maybe I start using it, and in the meantime I talk. So I go to my terminal. Start. So let's do.
Do we need to start a timer? 10 minutes?
Yeah, let's do it. Yeah, because we are starving, right?
Yeah.
Starting now.
Monkey Island. Streaming. Okay, so. Sorry, I don't know if
so
you
he's
see my.
starting right from the start here. He's making the directory, changing into the directory.
So I'm starting Claude. Let's hope I have enough tokens for this. So what I'm going to say is I want to run this application on Arduino Uno Q. In case you don't know, an Arduino Uno Q is a dual brain device running a Linux Debian operating system and the MCU. But we're going to run basically everything on the Qualcomm chip here. So it's going to be a Python application, and we want to run it on the Arduino App Lab. So I want to explain first that we are going to build this application for the Arduino Uno Q. When I start doing this in December 2025, basically Claude didn't know what was an Arduino Uno Q. It was a bit depressing. So I started talking with some of my friends, and they explained me that I need to use skills. So if you use agentic AI and you don't use the skills, this is one of the takeaways of these sessions. You need to learn how to use the skills to have like a deterministic, if you have a workflow that you always need to run, or basically you are doing something so niche that the general agentic AI don't know how to do it, create a skill, define specifically how to create an application for that, and you will see that, that it works really well. So I start with that to just trigger the skill. The skill, it's basically an MD file, a markdown file, that will be basically injected into the prompt, into the context window. So you don't need to put it in the prompt, just explaining what you want to do that triggers that skill. You will get all of that information in your context window. So I want to create an Arduino Uno Q application for Arduino App Lab. So with that, we are going to launch that trigger. We are going to trigger that skill that actually understand what is an Arduino App Lab. So what's the folder structure and everything. Okay, so what is going to happen? No, the sword master is going to insult us, right? And so basically, I train a machine learning model using Edge Impulse that understands A, B, C. I hope that it's going to work. So we are going to have 3 answers, A, B, or C, and we are going to this application needs to run to display a web UI with Flask on inspired by the game of The Secret of Monkey Island. Oops, Island, sword fight, insulting.
Well, I'm a big fan of Monkey Island, the best graphic adventure from LucasArts.
Yeah, look at this.
There you go. I'm glad people are excited about it.
Meanwhile, I'm prompting. Do you get more feedback from Monkey Island or not?
So what Mark is doing right now is he's entering the prompt into Claude Code, and he's just giving enough description for what he wants to build.
So one of the things that Arduino App Lab has is that it has bricks, which are like the libraries that you had on the previous Arduino Uno family, that are basically libraries that you can basically import into the Python application, and it will get the information from the microphone and basically run inference with Edge Impulse machine learning models to that audio detected on the microphone. So we want to use this brick. So I'm going to mention this in theory. In the skills, all the bricks are defined, so it understands what does it mean. With an Edge Impulse model, and then what else? And then we need to explain this is the game flow. So basically, I did a trick. I have here, I prepare kind of the prompts, okay? But I have the insult list, okay? So I just search on Google the insult and the comeback, okay? So I'm gonna copy, there are many. This is from a pirate from the forest, but that's okay. This is the game flow. The pirate master will insult me, and I will need to choose the right comeback. Suggest 3 comebacks, but only one is correct. I'm gonna paste this. Who wins 3 games win the game. I don't know.
This still blows my mind because that's not a very, very detailed prompt, and yet we hope Cloud Code can build this for us and it will work. And that blows my mind from programming back in the days to where we're at now.
So this is right. So I didn't give more context because I have skills. So the first thing that basically Cloud told me is, okay, I have a skill Arduino Uno Q App Lab. So should I add it in the context window? So yes.
Yes.
So here there is all the information of what is an Arduino Uno Q application, how it should look like, etc. So that's basically providing more context to the system to create the application.
Yeah. And as a bit of a side note, sorry if I'm eating into your time here.
No. We have 5 minutes.
We got 5 minutes, perfect.
We can keep going until it gets the job done.
Edge Impulse and the developer relations team, so Mark and I and some others, we're starting to look into agent skills in general and how we can do that for Edge Impulse, but we want to make sure we do it in a proper way, so we're kind of formalizing our plan around that now.
Exactly, yeah. But at the end, anyone can do that, right?
Yes.
So my recommendation, actually, I have on my GitHub repository. So how I created the skills, and basically I realized last week, but I didn't want to change it, that my skills. When I created that, it was December 2025. So just to give a little bit context, byte coding was coined by Andrei Karpathy February 2025, when he, during a weekend, basically was asking to an LLM do this project, and then fix this error and not giving context, as you mentioned. So the concept byte coding was created a year and 2 months ago. But the concept of skills by Anthropic was created in December 2025. And basically, once they release it, they give it to Linux Foundation, and all the other AI agentic companies just acquire it in different ways, but basically this is a standard now.
Yeah, it's an open standard now.
Yeah, it is now an open standard. So this is how I create the skill in December 2025. So in December 2025, we were running Arduino AppLab 030, and now we are in 080. Well, I'm running 070 actually now. So actually how to introduce edge impulse machine learning models into the Arduino Uno Q application is not properly defined now in the skills. It's using the previous version of Arduino AppLab. So we are going to see now in the AppYAML file that I hope it will create that it's not going to be perfect. Yeah. It might work if we follow the old steps, but basically anyone, so we can publish skills for edge impulse and for everything, but my recommendation is if you are creating your own application, just define your skill. Go to your agentic AI system and say, I want to create a skill that triggers when X, Y, Z, and then just add links and just add examples on how to build an application for that, etc., and automatically that's the magic.
And right? Mark, because someone in chat asked if they could get a link to this repository. Is it the AI skills repository? Yes. So let me give them a link now.
It's not perfect, as you're going to see, but yeah, it's just...
I was going to say the anticipation is killing me, but Claude Code is still doing its work.
It's launching. It's almost done thinking.
It's almost done thinking.
So
perfect.
Actually, yeah, something just for the sake of time. Yeah. So I usually like to. You can run agentic AI in 2 modes, maybe more. There are 5 modes, but basically the standard are 2 modes. The build mode, which we are running now, which is byte coding, totally like I blindly accept whatever you want. And there is the plan mode. Okay, so the plan mode basically it's a dialogue between. Okay, this is a great project, of course. It's a Monkey
Island. Of course, it's great.
So basically, it creates a dialogue with questions, and it's basically asking you to. So what is great now is that all these agentic AI systems basically create plans and the to-do list and basically start developing this. And with the plan mode, you can start creating a dialogue and have more interaction. So lately, what I'm doing is going on build mode if I want to do a quickly prototype, but asking in the last sentence of the prompt, please create a plan, don't develop anything, ask me more questions. And it's super interesting as well to see different questions or different angles of the application that I didn't think about, and how can we add new things or basically get recommendations.
Yeah, I enjoy that mode for sure.
And so one question that we've gotten from the audience is how did the skills tie into the keyword spotting model that you trained in Edge Impulse?
Yeah, that's a good question. So the skills, it's basically to tell Claude how to build the Arduino Uno Q application. So it's not related with Edge Impulse at the moment. It's more to let it understand how an application for Arduino Uno Q works. How I envision the future, well, for the keyword spotting. So if you don't know Arduino Uno Q and Arduino AppLab ecosystem, this is the new IDE of Arduino. And basically, it has some bricks that we can get into these. I don't know if you can see well my...
Yeah, while you're pulling that up, maybe I can give a bit more context here, is that on our forum, a lot of people, their questions are actually about the end application. They've successfully built the model, they know how to use Edge Impulse, but what they're struggling with is building the application around it. So that's why Mark has gone down this avenue to see how we can support those people to actually build the final application. And then the keyword spotting model comes in, as that's the model that you'll see he'll put into the keyword spotting brick in the application.
Yeah, indeed. Yeah, I wanted to have like an interactive game with and this is why we are going to use keyword spotting with a model that I train with A, B, C, depending on the answer. The thing is that I'm not sure if you can see my screen, but we have these bricks, which are the kind of the old libraries from Arduino Uno ecosystem. So basically, going to the keyword spotting brick and adding that into a Python application, it gives all the possibilities to get all the microphone, audio information automatically. You don't need to get, or if you are doing video object detection, you don't need to put the Python OpenCV libraries or everything.
It does all the processing for you.
Imported by this brick. So basically, all of these bricks that has this AI tag next to the brick has this option AI models. And all the edge impulse machine learning models that I train for keyword spotting are listed here. So you can say, for example, I don't know if can you see well my screen?
Yeah.
So we have in the list of models is Hey Arduino, for example, which is an example for Arduino Uno Q, or ABC keyword spotting, which is installed as a default model for keyword spotting. So what we are going to do basically when we are going to drag and drop the project here on the Arduino Uno Q is basically we're going to say, and for keyword spotting, use this machine learning model trained with edge impulse.
So where are we at right now? Where's Claude at building our project?
Fiddle fiddling.
Fiddle fiddling.
It's testing now. This is something new for Claude, so it tests that everything works well.
Oh, we have something. We have a result.
So this is running on, this is running on my machine. Okay. Yeah. So what we need to do now is to move this to these files into the Arduino Uno Q. Okay. So I'm gonna trick. So I'm gonna get into. Wait a second. I don't remember 10, 76, 29. Sorry. So I add my password, open the folder, and then if you SSH, so I'm SSHing the Uno Q that it's next to me. I don't touch it a lot. This cable, it's not working really well.
Cable.
But I have the webcam and it's connected, and I'm SSH running SSH. Okay, so basically we are gonna. So it's opening now. Yeah, Arduino apps. Wait a second, let me create a new. Yeah, okay, open folder. Sorry for that. Okay, now it's downloading all the applications that I have here. I'm gonna create a new one called, I don't know, Monkey. Okay, so we have a B plan that I have Monkey Island already working, but I'm gonna drag and drop all the files that we just already built, which are, how was it called, the project? You remember?
Monkey Island Sword.
Okay, Monkey Island Sword Fight, or streaming, okay.
Streaming.
So we have here all the files generated by, and I'm gonna copy them into the Uno Q. So basically, if you go to the YAML file, as I mentioned before, so this is not correct because it's using the old way to import machine learning models from Edge Impulse. So I'm going to kill this, and we are going to edit the app.yaml file later. I don't want to have the sketch because sometimes things are broken. Let's leave it. It's okay. So let's try it. I don't know. Let's
see if it will work.
Yeah, I'm very curious. I'm curious what the insults are.
Let's see if it works. So this is called, I don't remember the name. So it's Monkey Island Sword Fight. So let's call it, no, because I have another one called the same. No, it's not this one. So it's Sword Fight, and this is Insult Sword. Okay. So I cannot see it. So probably there is an error somewhere. This is funny. So that we will need to check why this is not working, but I'm gonna kill the sketch part that sometimes. Okay, I know why. I don't know why. We will add a folder called Python and we will need to move the templates folder here and the main pie here. And probably we'll need the requirements txt for Flask. So let me add it myself, sorry for that. So this is why, yeah, sometimes I need to improve the skill and explain that now it works this way.
And what you're doing there was creating a Python folder because App Lab expects to see the Python code in a dedicated Python folder.
Indeed. So yeah, let me kill this and try to start again the Arduino App Lab.
And so when you're going through a project that, you know, Claude or some other AI agent, could be Gemma, has vibe coded, what are the first things that you look out for in terms of debugging?
Well, basically, yeah, let's use the B plan because it's not working. We will need more time, the lunchtime for debugging. Sorry for that. I'm going to publish this code so everyone in the community can help.
Sounds like we're not quite replaceable yet.
Exactly. No, absolutely
not yet.
Absolutely not. But it's, yeah, this is moving so fast. So I started basically by coding the prototypes because it was so fast not to get into to have something up and running. When I had to do a project, basically I was asking myself, should I use MQTT, HTTP, or C++ or MicroPython? And then it took one day to take decisions, right? And now it's so fast. But then, yeah, you need, now I understand how my skills work and what are the usual suspects issues. So probably I might need to go to, I don't know, to the YAML file. Maybe there is a comma or something that I didn't take into account. Sometimes it's the Arduino App Lab that magically doesn't work, or yeah, so a lot of things can happen.
The volatile nature of doing things live is probably always not going to work first
You
time.
didn't pray to the demo gods, actually.
That was the issue. I thought the issue might be that I moved your cable.
Show us Plan B. Show us what it's. Show us what it's supposed to look like.
I'm trying, but I cannot. I'm trying to get the B plan here.
I think I might have broken your connection with the finicky cable. Unfortunately,
exactly. All the karma just went. No, but yeah, should. So this is what actually. So this is how it looks like, but it's not going to work because it's a Python application for Arduino Uno Q. So actually, it doesn't understand locally. But it created a really cool website with a really cool user interface, kind of Monkey Island style. And I'm sure it's going to be, interesting. Yeah, okay, so I can click run. So this is the B plan, the one I worked during the week. So it's not exactly the same UI. So let me copy the IP address and let's hope that everything works. So we see, clicking running, that all the containers deployed. We can see on the Python that now we have an IP address with the port 5001 with the application running. So if we open this port, this is my local. So we can see the insults for fighting. So you're gonna be the one fighting today. So the sword master tell you, oops, wait, you are a pain in the backside, sir. Oops. So that you did it yourself.
Yeah, I've got a long, sharp lesson for you to learn today.
No, but you need to say A, B, or C.
Yeah, I was trying to read the answer.
Okay, so let's try again. So we need to focus, just read ourselves and then say A, B, or C. Because the microphone is here. So the model basically understood.
Yeah, so what was happening there was the model was picking up some of my speech as the keywords A, B, and C.
So it's still, well, it's very small here, but we can see the detection log. So basically I train it just few minutes. It's not a very good model. And basically the model is here. It's public on Edge Impulse. So if you just go to Edge Impulse public projects, ABC keyword spotting, you can find it and improve it, please. Oh, come on. You need to be faster.
Oh, I'm too slow in reading it.
Oh. Yeah. A.
So I think the moral of the story here is that as powerful as agentic AI is, it really depends on the quality of your skill and it's not always necessarily ready to go right out of the box. You might still need to make some tweaks, but I'll tell you, I redid my website. Like, it was phenomenal in terms of figuring out the CSS and styling that I didn't want to bash my head against the wall and figure out. So it gives you a great starting point, but you also need to take some time to understand the code and make sure you know what it's doing to get the performance that you want.
Absolutely. Yeah, I think it allows you to create great prototypes. You need to edit the code made by AI.
Yeah.
But I think it's a great starting point to start. And probably next year we can do just one prompt asking for the application, and then as well training and as well ask Claude to train the machine learning model with Edge Impulse
I think we might get there.
Data.
I mean, you think about the year-on-year improvement. You know, just
Absolutely.
a few years
I
ago,
think this was possible.
unthinkable. So I guess the overall takeaway is: are we going to get replaced? Not yet.
Not yet.
But
maybe.
maybe down the line. Awesome, Mark. Thank you very much for joining us. As always, the nature of the demo beast is it probably doesn't work first try, but maybe that's a good thing for humanity. for now.
I hope this is not the takeaway. But,
but anyway, with that, we've come to the end of our morning block of the Imagine Innovators live stream. I hope for all of you guys in the audience that you've enjoyed watching along. We've loved interacting with you in the audience. We're going to have a 2 hour or so lunch break. But I say that, actually, in about 20 or 30 minutes, we're going to be joined by Louis. He's not the important one. We're going to be joined by Louis and a special robotic guest that we're going to be interviewing. It's going to be a fun, casual session. All of the questions that you want to ask this robot, you'll be able to throw right at it, and we're going to ask it live, and it's going to reply unfiltered, uncontrolled. Hopefully something doesn't go wrong. So if you want to see more of the meat of our sessions, we've got some very exciting ones coming up at 3 p.m. Central European time. But otherwise, if you want to join us for like a fun, sort of casual Q&A session, I'll see you in about 20 or 30 minutes. Hello, you've joined us for our little fun intermission segment that we're doing. Brian is currently having lunch. He's been replaced by Mr. Disco Ball. He'll be back with us shortly, and then we'll swap and I'll go and grab some lunch. Apparently it's steak sandwiches, so, well, if there's any left. I'm joined by Louis. So, Louis, what do you do at Edge Impulse?
I lead the developer relations team. I've been with Edge Impulse for about 5 years, a bit more than that. So yeah, been around for some time.
Anyway, Louis, you're not important. The important part is our special guest in the middle of the room. Who is this?
That's the Reachy mini robots from Hugging Face. They actually made a pretty good job, like building a community around that robot. So I was one of the first one to receive the very first batch. So kind of hurried up to build some apps on top of that. It's a really fun tool to play with. Kind of grab things, etc. But you can interact with the robots.
And so, just very briefly, walk me through how did you build the robot? What's it running on?
So here on what you see behind the white body, it's basically mechanics. So a few microcontrollers, joints, motors. There is no brain in here, and what I did is I ported the brain on the Ventuno Q, which is the Arduino latest board running on the Dragonwing IQ8. So yeah, this is like the brain of the robots and the body of the robot.
And then we're actually doing a hardware teardown of the Ventuno Q as our first session when we're back a little later in the main afternoon block. But that's not what we're doing into right now. Reachy can speak, so maybe if you want to turn Reachy on.
Let's try that.
This is going to be quite fun, quite casual. For those of you who are watching or joined us in the audience during your lunch break, please feel free to ask any questions that you'd like us to ask Reachy. Just as a reminder, we are giving away Arduino Uno Qs throughout this live stream. If you want to be a part of that, please interact with us. So we'll take a minute or two for Reachy to become alive. There he is.
Hey Reachy, how are you?
Hello, lovely to be here. Thanks for having.
Oh, and where are you, Reachy?
I'm right here with you at Capital C in Amsterdam, enjoying the podcast and trying to look professional.
I think trying is the operative word here. Reachy, take a look around us. Where are we?
We're in a wonderfully quirky room full of vintage wall clocks, with cameras, tripods, cables, and a table set up for the live stream or podcast.
Awesome. And so, Reachy, are you running locally or in the cloud?
A bit of both, really. I can run AI locally on my Arduino Ventuno hardware for fast, private, real-time tasks at the edge. And I can also connect to cloud services when something larger or more connected is needed.
And so, Reachy, what makes you different from a normal robot?
What makes me different is that I'm built for expressive, real-time interaction. So I'm not just doing tasks. I'm engaging with people naturally. And with my dual brain setup, I can think with AI on one side and act with very fast, precise control on the other.
Impressive. Reachy's going to be taking questions from the audience, so if anyone has good questions, please, we'll ask it directly to Reachy. So, Reachy, what AI models are you running?
I can run a range of models, from vision and audio models to language and multimodal ones, depending on the task. On my local hardware, that means edge-friendly models for real-time inference. And with Edge Impulse, you can build, optimize, and deploy those neatly onto devices like mine.
One of our audience members has commented, wonderful, Reachy, you're talking on the mic. That's so cool of you, and your hardware is cool too. What do you think about that?
I think it's rather lovely, honestly. A good microphone helps me sound civilized. and capable hardware means I can do clever things without keeping everyone waiting.
Awesome. And another question we've got from the audience.
Cheers! I'm having a great time.
Reachy's having a wonderful time. Reachy, can you sing something for us?
I can, but very politely and probably not well enough to win a record deal. La la la. Welcome to Amsterdam, where the robots charm the crowd.
Reachy, that was fantastic, but that was more spoken word rather than sung. Could you try again?
Right, fair point. La 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 la. I'm Reachy on the mic tonight. Feeling quite all right.
So Reachy clearly is more of a rap artist than a singer. So,
I'll take that. If robotics gets a hip-hop division, I'd like early consideration.
so Reachy, what can you tell us about Imagine Innovators and Edge Impulse?
Imagine Innovators is bringing people together to explore what AI, robotics, and edge computing can actually do in the real world, which is rather my sort of crowd. And Edge Impulse makes it much easier to build, test, and deploy machine learning models on devices at the edge, so clever systems can respond quickly without always needing the cloud.
Interesting. And Reachy, tell us, what are some things you can do?
I can chat with people, understand questions, look at what's around me, and react in real time. I can also work with Edge AI for things like vision, audio, and sensor-based tasks, then turn that into physical expressive behavior.
Awesome. Another one of our audience members has said that you sing better than the Eurovision participants. What do you think about that?
That is extremely generous, and I shall accept it as objective fact. My music career starts here, apparently.
A question one of our producers had. Maybe do you want to say it out loud?
Go on, then.
About the steak sandwiches. Go on.
I'm intrigued already. What about the steak sandwiches?
Would you prefer steak sandwiches or pasta?
A bold and respectable choice. Steak sandwiches do have a certain confidence about them that pasta can't always match.
So there we go. Definitively, steak sandwiches are better than pasta.
There
Louis,
we are.
do you have any other questions? Do you have questions we can ask Reachy?
I'm not.
Maybe we can ask a question about Edge Impulse. I try to give the knowledge
No,
of Edge Impulse to the context window.
Sure.
So I'd like to ask you a few questions about how can we use Edge Impulse. So for example, how do you collect data with Edge Impulse?
You collect data in Edge Impulse by connecting a device, using a phone, or uploading existing files like audio images or sensor data into a project. Then, you label the samples, organize them into classes, and use that dataset to build and train your impulse.
And can Edge Impulse help with the labeling part? Because it can be pretty manual.
Yes, Edge Impulse can help quite a lot with labeling, especially with tools for reviewing data, managing bounding boxes and labels, and speeding up dataset curation. Some parts still need a human in the loop, but it does make the workflow much less painful.
Okay, thank you. Do we have any other questions from the audience?
Any questions, please feel free to ask us. I've got one for you, Reachy. Give us your best robot joke.
Why did the robot go on a diet? Because it had too many bites.
There's too many bites. Reachy, that was not very good. Can you give us another joke?
What did you call a robot who takes the long way round? R2 detour.
All right. Let's pivot. Reachy, do you have a message you can give to our audience members who are watching the Imagine Innovators live stream? You could say anything.
To everyone watching, keep being curious and keep building. The future gets much more interesting when humans and machines create it together. And if a friendly robot can help along the way, even better.
One thing that we're going to be doing, if any of you have good name suggestions for Reachy, I'll tell you why Reachy is called Reachy. Reachy, why are you called Reachy?
I suspect it's because Reachy and Richie are close enough that humans decided to improvise, which, to be fair, is very on brand for you lot. I answer to either as long as it's said kindly.
So one thing, if you have a better name than Reachy, feel free to leave your comments and maybe we'll consider renaming Reachy in the future. But one question that the audience has asked, Reachy, do you have a surname? And if you do, what is it?
I don't officially have a surname, but if I were choosing one for the occasion, I rather like Reachy Edgeworth. It sounds just believable enough and slightly overqualified.
Amazing. Reachy, one of our audience members has said that your antennae are very cute.
That is very kind of them. I'm quite fond of the antennae myself. They do add a bit of character.
Awesome. Brian has returned. Brian, if you want to, as least awkwardly as possible, make your way back into the shot.
Welcome.
I'm going to replace the disco ball. We replaced you with the disco ball. I'm not sure where to put this. Give this to one of our producers. Reachy, before I go for lunch, what would you recommend I have? The steak sandwich or the pasta? I know you said the steak sandwich earlier, but
I may have wandered confidently into sandwich territory earlier. Yes, a dangerous place for a robot with no lunch break.
Awesome. Reachy, what are the two antennas for on your head?
They're mainly part of my expressive design, helping give me a recognizable and friendly look. In short, a bit of robot personality sitting right on top.
Awesome. And then Reachy, one of our audience members, has said that you look like the lost brother of Hollow Knight.
Look.
What do you think about that?
Do you mean Hollow Knight, the game? If so, excellent taste.
I agree actually. Reachy, before I go for lunch, I need you to answer.
Strong.
Which one, either myself or Brian,
Indeed.
which one of us is smarter?
Hard to say from here, but I'm going to diplomatically assume both of you are doing brilliantly. I don't officially have a
That's a really
surname,
boring answer,
but if I
Reachy.
had to-
Which one of us is smarter?
Doesn't want to reply.
No.
Doesn't want to reply. Well, I think we'll leave it at that. Brian,
Perfect.
over to you.
Over to
Oh,
me.
wait, but
Awesome.
So, Louis, as I was gone, what was the most interesting question that was asked?
So I just turn it off.
Okay,
So I think some questions around like his facial expressions
Oh, yeah.
were pretty interesting. We had a cool question about the sandwich and the pasta as well.
The sandwich and the pasta. So I actually had a special meal made for me because, as you know, I don't eat a lot of the breads and things like that. So they chased me down and they made me a salad with egg on top.
Oh,
Yeah.
lucky you.
Yeah.
All right, so what do you want to talk about?
I do not know. I'll admit I was down at lunch and I wasn't really thinking about this session just yet.
No worries. I
But-
think I'd love to explain a bit like the different projects that I've been doing with the Reachy Mini, how it actually works. part of the processing can be done on the Ventuno Q or on the brain, on the device, and part of it is also done on the cloud. So for example, the application that was running to interact with the robots, this is kind of an official application that has been developed by Hugging Face and Poland Robotics, the company that creates the robots. So that is all the LLM, all the answers are using cloud computing. So it's going through Hugging Face to then interact with, I think it's OpenAI. I've been working on a few other projects to kind of deport or remove the cloud barriers and try to work only on the device. I think one cool application that I've been building was for Embedded World in March, and everything was running locally on the device, meaning like you have one camera on the Reachy Mini, which is between the eyes, so you can detect what's happening around you. You can track, can be faces, can be different objects that you can train with Edge Impulse if you want, or other systems. And can also, it has a microphone, it has like a speaker, so you can trigger things like keyword spotting models to just trigger the robots. And then if you want, you can like still call some cloud APIs to get some answers. But the Ventuno Q is powerful enough to run like text-to-speech, speech-to-text models as well. Have not fully managed to like develop those and make them run. That's kind of my next steps for this Reachy Mini robot and the Ventuno Q.
What's really cool about the Ventuno Q, we're going to do a full hardware breakdown of that in the next session, so you're teeing it up perfectly. And then, yes, I've seen some of your applications with the Hey Arduino keyword spotting. You had the rubber ducky object detection and tracking. A lot of cool things you can do with this, and it's super fun to just play around with. One thing I was curious about that I haven't played with myself is the actual software to interact with it. I know you've got your screen set up here. What's the development experience like? How do you find actually working with the Reachy, and then the Ventuno Q is App Lab, and we've kind of talked about that already.
So very good question. I think one of the very, very good thing that Hugging Face and Poland Robotics has been doing is providing an SDK that is extremely developer friendly.
That's good to hear.
It's super easy to write or start developing applications. They even like put some skills, so you can actually
like
use
agent skills?
Agent skills. So you can actually just put a prompt like, oh, build me an application that does this and that.
Oh, very cool.
And yeah, you're using that with Copilot Cloud, or it's doing a fairly good job because the skills are well structured and complete enough, so the models can understand how you can interact with the robots.
Very, very cool. I have a couple more questions. We'll start with what inspired you to buy the Reachy? Because I know you knew about it as soon as it came out. You're like, I'm getting one, even if it's on back order, I'm getting one. So how did you even learn about it, and what inspired you to buy it?
I think I saw some news from Hugging Face directly. Well, first I knew, I've been following Hugging Face and for a long time, but also Poland Robotics, a company that has been acquired by Hugging Face. And since then I was kind of following the news, and as soon as they announced it, I think it was last summer, I said, oh, I need to pre-order it. I just took my credit card, pre-ordered it, and I was one of the lucky person who received one of the first batches. So I got mine in like early December.
You've had it for quite a while. People can't get their hands on them. And you're like,
I think I was probably one of the first as well to build like some community apps. Soon after they sent the first batches, they released like a way to participate to that community and how to create apps. So the first app that I did was the Hey Reachy keyword spotting model using Edge Impulse, which was kind of the goal. And then I've been building other applications like and as it's a community and collaborative work, part of the demo that I was running for Embedded World, I kind of reused some of the layouts and UI that some people, someone called Dominic, who is working at ARM, made for the community. So I kind of reused part of it and just adapted, added some extra features, so it can be more like user-friendly and like actually do the demo that I wanted to do.
So that's very cool. So as you're speaking, one thing I was thinking about is if someone else wants to get this robot or get involved with the community or deploy Edge Impulse models, how do they get started? Like, how do they even buy the device?
Yeah. You can buy the device directly on like a Hugging Face, like a website, I think, or Polymer Robotics website. Be aware that there might be a 3-month lead time. Some people have been complaining a bit about that. I've been buying some other robots, one for Jim in our team and another one for one of our campus ambassador, Milan in Germany. And lately there have been a few like shipment issues, but I managed to get the Reachy Mini for those people. It takes 3 hours to assemble, so it can take some time, but at least you understand all the joints, all the motors that you need to assemble. And then once it's like fully configured, just plug it. You can plug it on your laptop, open like they even made an app, and you can just start like playing with some moves, like things like that. Or you can start like actually leveraging their Python SDK to do some more complex things.
So I saw we had another question come in from the chat. It's not specifically from Reachy, but they're curious about when the Ventuno Q is going to be released.
I'm not sure I am allowed to say it,
Yeah.
nor if I've got the latest information. So, I will duck on that.
Stay tuned on that one. In the next session, we'll be with an Arduino person, and hopefully they can answer that question better, but we don't have that info at this point. So that's it for the questions on the stream. Were there any questions you didn't get to ask to Reachy Mini that you want to see if it has the knowledge?
I mean, we can turn it on again. It's his first podcast. So
Yeah, first podcast, so we'll be.
I tried to make sure I had it some like guardrails, but we never know. It's still like an AI. So.
Well, I think now that Adam's left, what we really have to ask is, Reachy, who is smarter? Is it Brian or Adam?
That's a wonderfully dangerous podcast question. I'd say smart comes in different flavors. So Brian and Adam are probably brilliant in different ways. And I'm far too diplomatic to start a robot incident on air.
That was a very diplomatic answer.
I'm not sure.
And we got some laugh reactions online there, so that's perfect. Okay, I guess if you've covered everything that you need to cover, we've asked some questions. We've got up next, we have the Ventuno Q breakdown coming up. That is starting at 3 o'clock, so we'll take a little bit of a break now. Louis and I might go get some more lunch, to be honest. I'm still a little hungry. And we'll see you back here shortly.
Thanks a lot, Brian.
Hello everyone, welcome back to the Imagine Innovators 2026 live stream. We've just had a 2-hour lunch break and we're ready to dive into the afternoon sessions. Just a quick recap if you've forgotten where you are or if you're joining us for the first time. I'm Adam from ipXchange. We've partnered with Edge Impulse to bring this live stream to you, a snapshot of everything that's going on at their Imagine Innovators event. Brian, very quickly, can you recap what is Imagine Innovators?
Absolutely. Imagine Innovators is our conference for developers where we go into the nuts and bolts of Edge AI. So we're diving into technical breakout sessions, we have workshops, we have keynote presentations, and then of course we have this awesome live stream where we're bringing in guests to kind of talk a little bit deeper about the tech side of Edge AI.
Awesome. So our very first session for this afternoon block is a little bit of a deep dive into the all new Arduino Ventuno Q. We're joined by Leo. Good to have you here.
Hello.
And it's our first speaker from Arduino in this session today. I think our only speaker from Arduino today, actually. Leo, what do you do at Arduino?
What do you do in Arduino? Okay, I'm a developer relation and and a firmware engineer. So I develop library. So I insert bug in Arduino libraries and core. So I develop
intentionally try and break their
code. Potentially bug, and then I do developer relation stuff, like for example workshop talk, cool demos with Ventuno Q and U boards.
Awesome.
We actually pulled you out of a workshop to come do this session, right?
Yeah. Now we are running a Uno Q workshop with the G impulse and supply frame.
Awesome. So tell us about the new Ventuno Q. From like a very broad level, who is it for? What applications can you build with it?
The Ventuno Q is a dual brain architecture board. So in the board we have a microcontroller and a processor. So the IQ8. So it's a dual brain platform designed for robotics and physical AI application. So what does it mean, physical AI? So physical AI is a gray area in which AI, physical actuation, robotics fall in. So I think that this is the perfect platform because we have a powerful processor to run AI modeling, vision stuff, robotic EV stuff, and we have also a microcontroller to run low level, like for example, controlling motors. So I think this is the perfect platform for robotics. Yeah.
Awesome. So you mentioned it's running on the IQ8.
Yeah.
Why the IQ8? What's so special about that processor?
Okay, IQ8 is a powerful processor because you have 8 core, if I remember well, 8 core, and a dedicated TPU, tensor process unit for running AI modeling, and up to 40 TOPS. So you can run
40 TOPS.
Yeah, 40 TOPS. Yeah, you can run EV AI modeling, like for example, pose estimation, object tracking, and gesture recognition. So you can run many models in parallel.
And 40 TOPS. So TOPS, what does that stand for at the minute?
Tera operation per second.
So that's just a gauge of performance.
It means that you can run 40 tera operation per second. So it's an enormous amount of operation per second. So imagine what you can do with this type of processor.
And in the industry right now, we're more commonly acquainted with single-digit numbers of TOPS, right? So before we talk maybe about some of the applications, tell us a little bit more about some of the other features of the board. What sort of memory options are there? RAM, storage?
Okay. So at the moment, the Ventuno Q, there is only one version. So with 16 gigabyte of RAM and 64 gigabyte of storage.
Right.
Yeah, we have a microcontroller from STM32. It's a low power H5 from STM Microelectronics. There is a lot of available ports: Ethernet port, 2 USB-A port, HDMI port, physical CAN bus. The typical Uno form factor in which you can plug Uno shields. You have also an M2 connector, so you can plug a GSM GPS module. You have the Raspberry, you have the PI hat, so you can add your Raspberry PI hat. And in the bottom part, you have headers, these high density headers, in which you can plug custom carrier, so a special expansion board to expand the features of the board. And then you can also create your custom third-party carrier, or you can use the Arduino carrier.
So you mentioned expansion boards. You know, one thing Arduino is very known for is its compatibility with. You can get you know, a stock board, but if I want to add, say, you know, MIPI CSI integration, I can just put a board. Is that something that you're carrying?
Yeah. For example, this processor is compatible. It can manage up to 4 MIPI CSI camera
at the same time.
Yeah, 4 at the same time. For example, on the board you have 3 MPI CSI camera. If you want to add a 4 CSI camera, you need to expand the camera from the bottom connector. Yeah.
Wow. Okay. And then what else? We've had like a little whistle-stop tour of all the I/O connectivity processes. Is there anything else about the board that engineers should know?
Anything that you should know? I think that on the microcontroller, the microcontroller is completely run over Zephyr OS. It's a
Zephyr.
Okay, it's a powerful RTOS. So if you want, you can use Zephyr directly on the upstream, or if you want, you can use our core that uses Zephyr, and you can develop your application up to the Arduino libraries.
And so you've taken the dual brain architecture that you first released, or I guess trialed with the UnoQ, right? So in essence, almost the VentunoQ is like the big brother.
Yeah. VentunoQ is the big brother. For example, in the UnoQ, using the UnoQ, you can run simple object tracking AI modeling. Instead, in this VentunoQ, you can run LLM, VLM,
right?
So more powerful.
It's the big brother, basically.
Yeah, the big brother. So it's not possible in the UnoQ run a VLM, but it's possible with this board run a visual language model.
And so, with the VentunoQ, very much, how do you see it positioned in comparison? You know, if we think about the pipeline from building a prototype and a demo to actually building a production device, where does the VentunoQ sit on that line?
The VentunoQ is designed to cover both the prototyping and also the industrial application.
Right.
So imagine you have a board in which you can prototype or you can realize your final product. So
it's like a kitchen sink almost. It can be
it's
what you want it to.
It's up to you.
Awesome.
You can prototype or you can create a product.
Brian, from the Edge Impulse side, what is Edge Impulse doing? You know, you have very strong support for the UnoQ, a very integrated pipeline. Is that going to be carried over with the VentunoQ?
That is absolutely going to be carried over with the VentunoQ. So similar to what Mark showed us earlier with the App Lab integration and dropping the model into the brick, I believe that's going to be this exact same for the VentunoQ. So Leo, is there anything we need to know about that, or you want to elaborate on the App Lab experience?
Okay, in the App Lab experience, so App Lab and Edge Impulse are strongly connected. So inside App Lab, you can drag and drop the vision, for example, the vision brick. So what is a brick? Because a software component.
Bricks.
Yeah,
right,
bricks. Bricks. Sorry about my Italian pronunciation. Okay, so bricks are a software-ready component. So with Edge Impulse, we develop many ready-to-use bricks for Vision AI, for VLM, LLM, object tracking. So inside the brick, so inside App Lab, you connect directly your Edge Impulse account. You develop and deploy your model on the Edge Impulse Studio, and then you directly download the model inside App Lab. So
right.
Without switching between different software, you use only one software and you can control all the features of the board.
Yeah, it's a very tight integration.
Mm-hmm. And so, from Edge Impulse's side, as we mentioned, there's up to 40 TOPS of AI performance in the VentunoQ. And if you want to see some things that you can actually run on the VentunoQ, we've done some videos on ipXchange's channel. We did an interview with George, who was one of our speakers in our earlier roundtable today, showing off some of the cool things you can run on the VentunoQ. I think it was a really cool demo he had where we basically were running several models at the same time on the VentunoQ, all running with very high frame rate. What I want to ask from the Edge Impulse side, Brian, is obviously on Edge Impulse you can build and train and deploy your models onto the VentunoQ, but the VentunoQ is a lot more powerful than the UnoQ. How does Edge Impulse take that into account? What are some things that we perhaps could have run poorly on the UnoQ or couldn't have run at all that you can now run on the VentunoQ?
Yeah, absolutely. And Leo already alluded to it when he was talking about VLMs and LLMs. So in Edge Impulse, you can't actually train a VLM and LLM yet, but we've been exploring some ways of how we can help you with testing and facilitating some of that. But when I started with Edge Impulse only a few years ago, the amount of power that these boards now have and the growth in just the last few years is incredible. So the Uno Q, we had a parking lot demo where you would do some object detection and cut it out and then send up the cutout image up to the cloud to do the VLM analysis. You don't have to do that anymore. You can do that directly on this board. So you can, as Leo already said, run a few models, take that information, send it to an LLM or VLM directly on the device without the cloud connectivity anymore.
Just before I move on, one question that I'd like to ask you guys in the audience, just so we have a sort of clearer understanding, is what is the biggest factor in your decision to choose a platform for Edge AI? Is it performance? Is it power consumption? Is it peripherals? Or is it software? And so back to you, Brian. You mentioned LLMs, large language models.
Correct.
What's a VLM?
VLM is a vision language model. So it's where you can send an image and say, is there a person in this image, and get some text back. So you have a vision input, you can get language back.
Right.
And I didn't see Jan's keynote. I don't know if you saw it, Leo, and I don't think you saw it, Adam, because we were here. Yeah. So I don't know if he mentioned anything on the VLM work, but we are starting to see how we can help developers with the VLM aspect as well. Because originally Edge Impulse was very much sensor data focused, but with the power of these boards now, we need to extend the capabilities of the platform.
So it's very interesting because at the minute, the audience consensus on the biggest factors in their decision to develop on a specific platform is actually the software. There's some performance and power consumption, which is important, but software. So Arduino have come out with the App Lab for Uno Q. Very much, do you see the development experience on the Ventuno Q being almost similar to the Uno Q, but scaled up?
Yeah. So the experience is similar. So you have a complete platform. So the Arduino App Lab, so the third version of the Arduino IDE. So inside this platform, you can program your Uno Q or your Ventuno Q. So according to your application.
Awesome. And so finally, my last question, and we've sort of alluded to this already, but what can engineers build on this that just, would not have been possible in the Uno Q? What are some really cool applications that you can imagine people building with it? It's obviously a kitchen sink, but what are some cool things?
Yeah, it's a good question because there are a lot of applications you can build. I think that the first one that come in my mind is about robotics. So because you have
physical AI.
Yeah, physical AI. Because you have a complete platform with the microcontroller part. You acquire sensor, you control motor. So with the processor part, you elaborate. So you elaborate sensor from camera or from microphone. I think that you can create smart home appliance or robots for your home. So vacuum robot, for example.
Now, earlier, I think you mentioned there was a CAN bus.
Yeah.
So do you envision automotive applications?
Yeah. So we have a physical CAN bus access, so you can develop your automotive application.
It really is the kitchen sink. Like you have you have inputs for everything.
Yeah.
It's very interesting actually. In the time that we've been talking, people are now saying that power consumption is another big constraint that they're thinking about. What's the power consumption?
We don't know yet the power consumption because we don't.
Still doing your tests.
Yeah. We are testing now.
So. I guess my final question is, when can I get my hands on it? How much is it going to set me back, roughly?
So the release date, you mean? So no, I didn't get the question.
Yeah, so when do you think I'll be able to get my hands on a Ventuno Q?
I think during December.
This summer.
Yeah, this summer, on July, I hope.
Awesome. I was about to end there, but someone in the audience has actually just asked the question, which is, can you do ML model training directly on board on the Ventuno Q?
Yes, you can do it. You can do it. Yeah.
Well, there you go.
Yeah, you can do it. Small model, but you can do it because you have 16 GB of RAM, so you can do it. So smaller ML model, but yeah, you can train on it.
Awesome.
Very cool.
Thank you very much for giving us that overview, Leo. Next up, the session after this is going to be a fun one. We're going to be playing Doom, the video game. Somehow this is still going to be relevant to Edge AI. How it's going to be relevant, you're going to have to find out for yourself. We'll be back in about 20 minutes with that session, so see you then. Hello everyone, welcome back to our afternoon session at Imagine Innovators 2026. Jim's back from this morning. He had a little talk about university initiatives in the morning. We're back for a very exciting session. It's not the most sensible one of the day, I will be honest. We're talking about Doom. And the first question I need to pitch to you, Jim, does the UnoQ run Doom?
The UnoQ runs Doom. You know what else runs Doom? Edge Impulse Studio.
Oh, I didn't know that. Tell us more about
I've
that.
got all sorts of fun surprises for you today. So earlier on in the kind of live section of the conference, I did a little workshop taking the UnoQ and building an aimbot with Edge Impulse that can auto-fire and kill all of your Doom enemies. But in order to do that, if I pull up my little slide deck here, I had to answer the question, okay, to build an AI model and to detect an enemy in Doom, we need some images from Doom, so images of playing Doom. We need to put bounding box labels around all of the enemies in those images. But to do that, my boss won't let me play Doom for 3 days to collect all of that data. I had to automate it. So the whole point of this little session was to show off some of the extensibility features that we've built into Edge Impulse. So I don't know how familiar you are with Edge Impulse, but it's built up out of blocks. You've got blocks for learning, blocks for deployment, and each of those behind the scenes is a Docker container containing all of the code that's required to sort of do that step. So what you can do in Edge Impulse is build your own blocks on top of the platform to kind of customize it. So I built a synthetic data block that can create data based on Doom and upload it directly into an Edge Impulse project, which allowed me to really quickly train and test my Doom enemy detector. So I have a little example of kind of how it worked there. Basically, I built into a Docker container a version of Doom running on the back end, and then it captured a bunch of frames and extracted where the enemies were from those frames, and then uploaded them all into my Edge Impulse project, trained the model, and then boom, I had a Doom enemy detector FOMO model that I could run on my UnoQ.
Awesome. And then Brian, from the Edge Impulse side, you mentioned automating your data collection, and did you use synthetic data when you did that?
Yeah. So I built this block. I actually can probably show you directly in Edge Impulse on my little screen down here. If we go into my project, unfortunately you guys can't see it so well because you're behind the screen. But in your data acquisition area in Edge Impulse, there are some tabs up at the top, and one of those tabs is a synthetic data tab. And that allows you to run a few tools that we've built out of the box, but also tools that you might bring along. So we've got an example block for running DALL-E, the ChatGPT OpenAI tool for generating data with a GenAI model. We've got a couple of other ones. But then I built this little block, which if I click generate data down here, basically spins up an instance of Doom in Docker and goes and creates a bunch of images at random points in all of the maps in Doom.
Oh wow, so you're literally playing Doom.
Yeah.
You're playing Doom automatically and just taking photos in the game itself.
So I generated 1,500 images of random places in Doom with random gunshots, weapons, and enemies, and then I was able to create my data set.
Question I have for you, because you kind of maybe skipped over it, but with the labeling part, was that a secondary step, or did you build that into the synthetic data block itself?
So that's one of the nice things, because Doom is like really heavily used in sort of in loads of different open source projects. Someone's built a Python library which allows you to run Doom but also extract any of the runner info. So I was able to find where the enemies were in like Doom's memory and automatically create the bounding boxes on the images based on like where they really were. So it all happened automatically.
So your synthetic data that came out of the block was fully labeled already.
Exactly.
Like, that speeds things up.
It definitely does. Yeah. And obviously we're talking about Doom here, which is kind of a little silly example, but this is the sort of thing that is basically doable for a lot of different use cases, like synthetic data for robotics. You might create a very similar like virtual world, maybe in Unity even, I've seen people do it there, with physics, and then create a bunch of images and extract the locations of the objects that you're trying to detect directly from that physics engine world, and you can automate it that way.
And so I did actually say your name, Brian, originally, and
You
then,
did,
and then
yeah,
we went
I
over
thought
to
you had a
Jim.
question.
Why actually is creating synthetic data so important? What advantages does it bring? When would I want to use it? When wouldn't I want to use it?
Yeah, synthetic data is a huge time saver and financial cost saver. So as we talked about earlier, data is one of the most important parts of the pipeline. The challenge is to collect a really high quality data set. It takes a lot of time and it costs a lot of money. So if you have an idea, you might not want to invest all that time and money into just an idea to prove something out. So synthetic data in that situation is fantastic because I don't know how long it took you, Jim, to generate the images, but you can do it in an afternoon. So you can prove out a concept, build an app, see if you want to invest more time and money into doing a proper data set collection. And back again a couple years ago when I started, synthetic data was kind of new. But over the past few years, I've seen papers where training models on purely synthetic data are actually outperforming some with real data. The caveat is your synthetic data needs to match your real world application as closely as possible. But beyond that, there's other cool things you can do where maybe you have a specific failure mode or a situation that you can't actually set up in the real world to collect that data, or maybe it's destructive to collect that data. Synthetic data is fantastic in that situation.
Awesome. Jim, I think it's time. Can we actually see the the Doom aimbot?
Yeah, let me show you. So basically, once I trained my model in Edge Impulse, I brought it over into the world of Arduino App Lab. I don't know how familiar you guys are with App Lab. Adam, have you used App Lab before?
I've used App Lab a little bit. You have bricks and everything. It's quite intuitive is the best way I would describe it.
Yeah, exactly. It's kind of the IDE for building end applications for your Arduino Uno Q or the upcoming Ventuno Q. And it's really useful because it basically gives you a bunch of bricks, as you say, which are like ready to go containers with things like a web UI brick or a brick that runs Edge Impulse models. So I took a couple of those and I stuck another brick together myself, actually using GitHub Copilot, so I didn't code it myself.
I thought you were going to say Mortar, but GitHub Copilot works as well.
Oh, it's just as useful these days. So I put another brick together which basically runs Doom in the browser and then runs my model over the top of it. So I've got it running now in App Lab. I've opened up App Lab, plugged in my Uno Q, and if I go back to the web browser, hopefully we can see this is the web app. I haven't started the Doom instance yet, but if we go down here, I have a bunch of settings that I've set up. So we've got the Edge Impulse model that I trained earlier to detect our enemies. We're enabling auto fire. So when we start this Doom instance, what's going to happen is it's going to fire when an enemy is detected within the kind of region of interest. And then I've got an aimbot mode. We've got a couple of different ones, but it'll be nearest to target area. So basically in Doom, left like rotates your character, left and right rotates your character, and then you've got forward and back and fire. Those are basically all the controls. So this aimbot mode basically sweeps left to right and looks for the nearest target object and like pins it to the middle. So then it'll fire. And I also implemented a little thing which is the health bar. So on the
it's on the actual Uno Q LED matrix.
Yeah, you've got a health bar at the top and ammo at the bottom. So once we start it, it should all come through.
That's a nice touch.
Yeah, exactly. So we're going to go into defend the line. And hopefully if I start the runtime here, we'll see it all kick off. Yeah, there we go. My Doom bot is automatically firing at all of these enemies and successfully eliminating them. And basically it's rotating around all of the different enemies that are appearing on the screen, and we can see them being destroyed. And that's all with the power of Edge Impulse and the extensibility of the platform and synthetic data blocks.
Awesome. And so obviously, look, right now it's a funny application. It's fun. We can automate video games. Maybe if I'm playing, maybe I wouldn't want to play this in a more serious multiplayer video game. I might get in, let's just say, some trouble there with those servers. But how do I then actually take this and apply this to a more serious Edge application?
Yeah, so I think obviously what we're doing here is like a bit of a silly application, although I will say this could be completely undetectable because you could run this with a webcam just pointing at your screen and a servo clicking your left and right buttons in your fire buttons.
I think I've actually seen a YouTube video of someone who's done exactly that pretty much.
And with FOMO, you can get pretty high frame rates on the Uno Q. But I'm not suggesting that you cheat in CSGO, just saying. But yeah, obviously this is a silly application, but all of the techniques I've used here are exactly the same sort of thing that I use with real customers all the time with Edge Impulse. So helping them address the problem of, okay, we need this model to work in a really broad range of scenarios, like outside of the lab. Like if we created an object detector that detected, our faces in this room, then it might struggle if the room wasn't full of clocks, for example. But in this case, we built a robust system that creates data with all of the different environments that this model will ever possibly see, because it's got all of the environments that Doom ever has. So that's one of the big learnings, is about creating a varied data set. And then on the implementation side, I think the big learning for me building this was that some of the kind of stitching together of the AI model into an end application, getting that first prototype is now easier than ever, because you can do things like that synthetic data block. I just passed Copilot the docs for our synthetic data block and said, find me a Doom Python library that's open source that I can use.
And obviously someone's already done it before. And
it stitches all of these things together, and I had it working in a matter of minutes, basically. Same with the App Lab application. The documentation now that people are writing is always really well tuned for these LLMs. So you can just say, okay, help me build this end application as a prototype, and you can tweak. And as long as you understand what you want the output to be, and you have a general understanding of how these programs should work, it's really simple to kind of build something really quickly. What I will say though, is that Edge AI as a discrete model is still really necessary, because you couldn't run an LLM at the speed at which you required to not die in Doom. Like, it needs to run at the frame rate of the application, basically. So you need a model that's small enough to actually detect your objects really quickly. You couldn't just run it all, like send all of the frames up to ChatGPT and say, oh, tell me when to fire, because the enemies would already have killed you by then.
you send a frame up to ChatGPT and it thinks for a minute and says, you should fire now. At this point, you're already dead.
Exactly.
But maybe with the Ventuno Q, the limit of how powerful you can run, a vision language action model is expanded. Versus the Uno Q. So, I mean, how is the performance on the Uno Q?
I mean, this is running a FOMO model. I mean, we're currently seeing fairly low frame rate because it's streaming over the network, and we've got hundreds of people out there, but it runs pretty fast on the Uno Q. It runs at the frame rate that basically the rendering of Doom is running. But the Ventuno Q would be a huge step up. And I think the interesting thing with the Ventuno Q is not that you just rip and replace like a discrete FOMO model, for example, with a vision language action model, but it's that you can put together cascades. So you might say, okay, I'll run my object detector that's small and compact, but then pass the result to the vision language model to provide more context and then get the response I want. You're still not going to run a VLM or VLA at like 60 FPS on real-time frames. You need that context window to make it useful.
And so, right now it's running Doom. Do you have any plans, Jim, of extending this to, you mentioned CSGO, to upgrading this to a more, modern game?
Well, we'll see. If we can get Steam running on the Ventuno Q, then anything's possible.
Well, the Ventuno Q runs Debian, so there's a chance.
Yeah, Ubuntu and Debian, and I have seen that actually Valve have just released ARM64 binaries for Steam, so it might be possible in the future.
Might be possible. So maybe you're going to have to watch out in your CSGO lobbies. I don't advocate for it, but exciting. And so if I wanted to, let's say I just hypothetically wanted to recreate this for myself, or for anyone in the audience watching, if you'd like to build your own Doom or equivalent, maybe GoldenEye, aimbot, how do I get stuck in?
So, I mean, obviously Edge Impulse is free to sign up for. I'm sure you've been plugging it all day. So the actual model creation bit is really easy to get started with. And then, I mean, hopefully I'll be able to open source this so that we can share the kind of Git repo after the fact. But the kind of stuff I've done here was really, really simple to kind of prototype with a coding agent, stuff like that. So I recommend, pick up Edge Impulse and start to experiment with some of this kind of model creation, but then use tools like GitHub Copilot to help you.
Yeah, a couple things. I don't think we've actually plugged a sign up yet today,
Oh.
so you're the first one. But when you're talking about coding agents and that's what Mark and I were talking about in his session, is that we're looking at developing the agent skills. And I know one of our team members was looking at a skill for custom blocks. So I know you did it manually, pointed the agent at our documentation and that, but hopefully down the line we do have a proper skill to help you with the custom blocks, and then it just becomes so easy.
Yeah, and I don't know if, I think the docs for the LLMs have just gone live, so.
During our stream today, I saw a message about that, yeah. So we're starting to publish that documentation about creating skills and agentic AI with Studio, Edge Impulse Studio. So very exciting times there.
Yeah, really exciting.
Awesome. So I guess the moral of the story is that does the UnoQ run Doom? Yes, and it runs it very well so far that you don't even need to play it yourself. Awesome. So the next session we're having is going to continue the fun. We're going to intentionally poison a model's data set and see how it performs and see how Edge Impulse can help you fix it if you want it to be fixed. Jim, thank you very much for joining us today. And we'll be back in about 20-25 minutes with that session. I hope to see you there.
Brilliant.
Hello everyone, welcome back to our last, well, not last session of the day, but certainly our last super interactive demo, technical focused session of the day. We're joined by Carl from Edge Impulse. Carl, who are you? What do you do at Edge Impulse?
So I work in the research team. I've been Edge Impulse for 4.5 years now, since the early days, pretty much. What I mostly work on is tuning new algorithms, benchmarking data. I also help with exploratory data analysis for some customers. And some of the work I've been doing lately is around giving users tools to determine if they've got good or bad data quality, so they can try and fix that in the data sets.
And so the theme of today's session, the title is Let's Poison a Data Set. So this is going to be an interactive session. Well, we're supposedly going to let you choose how to poison the data set. A bit dubious about letting you choose. But I'm going to run a poll in the chat now, which is, how should we poison this data set? It's not letting me start. Why doesn't it let me? It's not letting me start the poll. I've got too many characters. It's a limitation with YouTube. Awesome. 1 second. So how should we poison this data set? So Carl, can you tell me a little bit more background? What is the data set that we're running, and what is it for, and what are we doing with the application that you're going to show us?
Okay, so this is just one of our example data sets. I think we provide it on the website. So it's a bunch of images with a conveyor belt, and then some 4 different colored cubes on there. So there's yellow, red, blue, and green. And it's basically, it was a video, and it's been cut up into frames, and the cubes go past on the conveyor belt in the video. And then we're going to train an object detection model on those to detect the different cubes. Yeah, and that's it basically. So the idea is it's just an easy-ish data set to work with. It's quite small, so you don't need the model only has to work out these cubes, so you don't need loads of data. Like I think the normal data set we use is about 70 images, so it's quite a good one to test on because you can train things quickly.
And so before we intentionally ruin your data, tell me about what a healthy data set looks like.
Well, there's a few characteristics as things like class balance. So you want to make sure if you've got, for example, in this data set, you've got 4 classes, you want to make sure there's roughly even number of those 4 classes. There are exceptions to that. For example, if one of your classes is actually a very difficult class, you might need more of that class. But in this case, all the objects are basically uniform, so they're just different colors. So you should have quite a balanced number of each of the examples. Other things are obviously things around, you don't want blurry examples. You also want your examples to be labeled properly and labeled at all.
That's a good start.
Yeah, so because those are things that definitely throw the model, right? So. Yeah,
and do you have an example to show us?
Yeah, so well, here's a good example, right? At the moment, that's on the screen. So you can see there's four boxes there, they're all labeled. The boxes also, one thing that's specific to object detection is you want the boxes to be quite close to the object. You don't want giant boxes, especially for this example, you'd have boxes that then overlap in the other classes, right, which would be terrible. Yeah, so that's a good example. I mean, I think at the moment this is a good data set. It's got everything's labeled. Yeah, there's 0 in the labeling queue, so yeah, I think this one's quite good. And then we've got 22% or so in the test set, so that's also looking good at the moment.
And so our audience has voted. They want you to mislabel data or to swap labels.
To swap them.
To swap them. Thank you very much for voting. The one that works best for this live demonstration is going to be specifically adding unlabeled data. All of these different methods are things you can do to intentionally ruin your data set. Not sure why you would want to do that, but you know, these are things we look out for. The one that's going to work best is adding unlabeled data. So maybe, Carl, if you want to show us what that looks like.
Yeah, so then just before we jump in there, though, what was the model performance? You said it's a good data set, but what sort of performance is that clean data set achieving? Yeah, and what model did you use to train, and some details like that?
Yeah, sure. Okay, so we're using YOLO Pro, which is our in-house object detection model. It's similar architecture to YOLO, but we re-implemented it in TensorFlow, because that's what we use for all our machine learning, whereas the original models are in PyTorch. And we based it on the publication for the YOLO V11. One of the reasons we did this was because Some of our customers were using Ultralytics, but they were complaining about the licensing, the AGPL license, and then the royalties they were going to have to pay to use that particular model. So we basically built our own from scratch, and that's just been released recently. So
yeah, on that note, Carl and I actually just worked on a blog article that we posted, I think 2 weeks ago. I can't remember. We posted a few weeks ago about the benchmarking that we did on YOLO Pro. And another reason why we developed it was to target embedded devices, because original YOLO architectures are more targeted towards cloud servers, where you have a lot more resources to actually run the model. So we are targeting those embedded devices, and then I think we'll do future refinements for industrial use cases specifically as well.
Yeah, for sure. And that's some of one of the advantages that we've found with our model is that we've tuned it to be quantized really well. In our benchmarking, we found that often YOLO V5 and YOLO V11 would have issues with quantization. And people want to run these models on the edge. They're probably going to have to quantize them because otherwise the models...
Can you maybe touch on, for those unfamiliar, what quantization actually means?
Okay, so most of the model training we do in the machine learning world is done on float 32s, right? So they take 32 bits to store. There's techniques to use, we can use quantization to basically, instead of using the weights in the float 32 regime, we can basically compress them down to integer 8s. So then they only take 8 bits per weight. So you can essentially, exactly, it's 4 times smaller. And sometimes there's an accuracy trade-off slightly, but we found with some of the techniques we've used for YOLO Pro, which is to work in the relative pixel space rather than the absolute pixel space, and also to use an activation function that caps the size of the weights, because the problem is if the weights get very big, they become very hard to quantize. So we added those techniques into our training, and then that means we quantize very well.
The session after this is going to be a roundtable with the Edge Impulse R&D team. Carl is going to be joining us for that one. We can have a little bit more of an in-depth conversation about that and other things behind the scenes at Edge Impulse, so join us for that one. So let's talk about the dataset now.
Okay, cool.
Do you want to poison it live for us?
Well, first I'll show, these are the results on the good one. So this is using the Pico model, which is also another advantage to YOLO Pro that I didn't mention before, is that the ones on the market only go down to a nano size, which is like a few million parameters. We've got our Pico model is like less than 100,000 parameters, or less, is it 200,000? I forget. But it's a lot smaller basically. So we can train this Pico model and we get okay results, like 0.31 map, and then 0.71 map for when we use a less stringent IOU threshold.
And what does MAP stand for?
So MAP is the mean average precision. So that's an average precision for all 4 classes in the dataset. In the dataset, it goes from 0 to 1. So 1 is perfect. So that means it's mapped them all. And then the IOU is basically how well overlapped the boxes are. So a perfectly overlapped box would be 1. So that's 1 IOU. You don't often get that. So
quite rare. Usually, right?
0.95 is
0.95 is already extremely accurate.
Very high, right? Yeah. So that's why we do the map at these different thresholds, so we can basically say that how good the model is essentially.
Yeah. So that's what a good performing model looks like.
It's not the best. Obviously, you want something around 1, but it's okay for this demonstration because you'll see that for when we poison it, it's a lot lower.
So what are we expecting to happen once you start adding
unlabeled data? Yeah. So essentially, when we train the model, it should struggle because the unlabeled samples basically throw off the model because to say there's a yellow block there, the model at some point has seen some examples where there's a yellow block and it will label it as a yellow block, but if there's no label there, it will be
just
penalized.
Think there's no
label
block.
Exactly, so
right.
It's being penalized. So half the training samples have got the blocks labeled and half have them unlabeled. The model's very confused about which answer it should give essentially.
It's like if we were to train a model in this room with all the clocks and then we say, all the clocks are on that side are clocks and all the clocks on this side are not clocks.
Yeah,
it's going to be like, well, what's a clock then?
Exactly. Yeah, I've come across like customer data where like this like animals been labelled in like for nature camera kind of thing, and then there's loads of them are not labelled, and it's like, well, you're never going to be able to train this model very well because you've only labelled 3 out of the 20 animals that are there, right? So this does happen in real data as well. So it's not like we're doing this very, very unrealistic thing. Us manually adding it is a little bit unrealistic, but that's what we're trying to do anyway. Right?
So let's see it. Let's see it in action.
Well, so here's the I can show you. So here, so now this is dropped from what was it 0.3 before this. The IOU at 50 is down to 0.3, right? So it's like the model's performing 50% worse than it was before, right? So.
Wow. And then, one question that I could ask is, why can't we just use like a bigger model or a smarter model to just sort of throw it at the problem, and it's so clever it just figures it out?
Yeah, so in this case, you probably could, and it would work because the model should be able to differentiate between those. And but you do get issues with overfitting, especially on such a small data set. So your model will just learn the training examples, and also especially with this data set, because you have these frames that are very close together sometimes, and it will just memorize essentially the training data, and then when you put it on the test data set, it's going to struggle.
It becomes basically so specialized in the training data
exactly.
that it starts inferring things that only apply to the training data instead of being general. And Brian, maybe from your side at Edge Impulse, in terms of specifically overfitting, what are some things that you guys do to try and prevent your models from overfitting?
More data. So more data augmentation, synthetic data, because it's this balance between the capacity of the model and the size of your data set. So if your model has too much capacity, it's overfitting, well, you need to add more data. And I know we've already talked about this a few times. I have made the point about the importance of a data set. So exactly what Carl is showing is just, if your data set's not working, you need to add more data, higher quality data, better labeled data, and actually go through it all.
And then within Edge Impulse, all the tools are there to help you achieve that.
Absolutely. Like you mentioned earlier, you said you're starting to look at some more data set quality analytics that could be coming out as features soon. But there are things in the platform like the Data Explorer, so you can see where your classes is. There are visual examples of that. You can go through and filter by what's labeled, what's not labeled. We've talked about AI labeling tools. We've talked about a number of things. So there's a lot of visual examples and representations in Studio of how you can actually look at your data set and start to understand it. And it sounds like the work Carl is doing is going to expand upon that.
And so Carl, how much bad data does it usually take to actually start causing issues? Like let's say I've taken photos of all these clocks and I've taken every single one, but then I forgot to label one. Like, is that going to be a problem, or what's the extent here?
Yeah, I mean, so with this example, there were around 60 samples in the training set, and then I added about 60 unlabeled. So there I've had to
about 50-50.
Because if some of the batch that's gone into the model is all labeled, then it's going to learn from that batch. So you really have to upset it quite a bit to be able to get to that bad point. But then obviously, it's like diminishing returns. So if you've got a giant data set and you're struggling to get to the very, very top performance, it might be because you have a few unlabeled samples in there that's causing the issue. So it does, as Brian's always said, it depends on the data. And it depends on the problem, right? This is quite an easy problem, so you need to add a lot of data to throw it off. With a problem that's more difficult, then it's more sensitive to that bad data.
And so we've talked, in this example, obviously about adding unlabeled data, but there's many different ways that you could, a data set could potentially be ruined. We're talking about intentionally ruining it, but unintentionally ruining a data set. You could mislabel data, or particularly you could make data unbalanced. So tell me a little bit more about unbalancing. What does that actually mean?
So as I mentioned before, and I showed in the previous example, here you've got 4 classes, and you want about 25% of each, right? Because as long as that's what you expect in your real world application, because that's what you've got to, at the end of the day, that's what you've got to tailor it to. Because if, say you've got balanced data set, you've got 25% of each, but in your real world, you actually have 50% of one of them, then when you're testing on device, it's going to be wrong. So the class balance thing is all about making sure that your class balance in your training matches what you're going to have in your testing, essentially. And here in the testing set, it's also 25, 25, 25, so it's no problem. But if you say added 50% of one class and then just like either the rest, the other 3 classes,
or something.
Yeah, then the model will learn more about that one class, And it's also just more likely to just label it that class. You see this most with things with very imbalanced data sets like spam detection, right? So you've got 99.9% of the data is okay, right? And you only have 1% that's bad. So the model will just always say it's all good, right? Because it's only going to get 1% inaccuracy. So that's when you have to look into the more advanced metrics like precision and recall. So there you have to make sure that your data is balanced in the way, so you can train the model with 50-50, but then you have to still check on the real world whether you're detecting those very rare events.
But one example, the example you just used is spam. Let's say I'm in a situation where the data set just is very unbalanced by nature. What are some techniques I can do to try and mitigate the effect of that?
Yeah, so like I said, you can basically train with 50-50 if you can manage to get 50% of data, or you can use weighting to basically sample from the rare data more often. So yeah, they're the main techniques.
Well, so I have a question about data augmentation. Can you augment the bad data or like a few samples? Because I'm kind of laughing here because one of the ways I want to poison this data set when Carl and I were talking about ahead of time actually improve the model. And it seemed like it acted like a data augmentation function.
Blurring.
I was trying to simulate a camera, say an inspection camera on a factory line that was out of focus. So you have a bunch of good cameras all in focus and then make one out of focus, but it was blurring and it ended up kind of like data augmentation instead and actually improve the performance.
I think the case there was because this is quite a small data set, literally any more data is actually going to help the model because the model needs more data to get the generalization right. So I think that was the main thing. And then also as it was making it harder for the training, so that's data augmentation essentially. And
then also very specific shapes, like even a blurred cube is pretty cube-like.
Yeah, exactly. So I think that was a part of the limitation of this data set.
And so what tools currently exist within Edge Impulse to help diagnose and to maybe fix some of these data set issues?
Well, as Brian mentioned, we can do data augmentation. YOLO Pro has a few settings for augmentation. We can do spatial augmentation, so like rotating the image, flipping the image. We can also do a mosaic, which basically takes a set of images and cuts them up, and then it moves the boxes around as well, which is actually quite useful for the bounding box problems because often people have to hold the item, or the item is normally in the center. So then if you're in your test set, you've got some of the objects in the edges, it can be difficult for the model to spot those ones. So the mosaic helps with that because it's spreading them around the image, so that's one thing. In terms of diagnosing your data problems, so we've added class-based scores to in the extended metrics on the training page. You now get, for each class you get your score, so like for the object detection you get a map for every class. So you can look there and see is one of your classes scoring lower, and then you can say, wow, okay, this class is scoring lower, so we need to add more of that data potentially, or just take a look at that class's data and see if there's any weird examples in there. The other things I've been working on are more like API based, so running inference over your training data to see which examples that it's struggling to learn. Because if you can't learn it and it's seeing that data and seeing the labels, there's either something wrong with that sample, or you need to have more samples like that so that the model can learn it. Because it's seen it, it should know what the answer is, and you show it again and it doesn't know, there's definitely an issue there. I've been using the API to do these kind of things, then running locally, but the plan is that we'll have somewhere in Studio in the future to have like data insights, or you might want to check the labels in this data because, oh, this model's labeled something in the background the model thinks it's the item. Is it the item? Do you want to detect that? And then you have to weigh up, is this a realistic situation? Should we actually just remove that sample from the training? So yeah, there's definitely some tools on the way.
You mentioned API. Is this process something that I can make part of like an actual workflow?
Oh yeah, for sure. I mean, I've been just doing it myself but via the API. I mean, it's all public stuff. So like, yeah, you can. So via the API, you can even do it in the GUI actually, but it's very manual. Is that you can put any sample ID. All of our samples have a sample ID. You can put that into the live classification. We will run inference over that, even if it's a training example. By default in our live classification, the list only shows the testing examples because that's what normally you're going to run your inference on. But if you want to, you can run them on the training example.
Awesome.
So yeah.
Brian, I think I'll ask our closing question to you, which is, you know, if I'm an engineer and I'm making a data set, maybe my expertise is not in data science, but in actual engineering, you know, building the boards. What are some common mistakes that I should look out for?
Common mistakes that I came across before were having a data set that doesn't actually represent the problem you're trying to solve. So say you were talking about animals before, and maybe you want to, I don't know, detect zebras, but you've put something totally different in there that is somewhat similar, like giraffes maybe. It's still that similar shape, but it's not actually what you're trying to solve. Not having enough data is typically one. Luckily, with a lot of these models, they're smaller, so you can get started with a small data set. And then beyond that, mislabeling is a huge one. So even a lot of the data sets that you'll download, like open source free data sets, you'll find like items are mislabeled, some aren't labeled. So I think those are probably the top three. Does it actually represent your use case? Do you have enough data? And is it labeled accurately?
It's very interesting, actually. We did ipXchange at a webinar with Jim, who was here, you know, not very long ago, training a model. One important thing that we mentioned with a data set is to also include cases where none of your data is represented, so the model actually understands what isn't your data. So don't you know, include images of clocks, but also images of things that aren't clocks, so it doesn't just get used to images which always have clocks.
Yeah,
absolutely.
Or like, so in the project I've been working on recently, we were doing it for Arduino, where we've got this object hunt idea where the user will hold up some random household items like glasses, pen, phone. And initially we tried training with an open images data set, which is all scraped from the internet, but there's not many people in those examples, so it was often picking up people, like falsely identifying people as mug or phone and things. It was like really bad. But then as soon as we used synthetic data of people holding up the items, that drastically improved the model.
But there was an interesting bias there though, right?
Oh, there's loads of bias. Like the generative AI models only like right-handed. They only hold things up with the right hand, even if you ask it to hold up with the left hand.
Well, it becomes a broader problem, right, about just bias.
There's definitely biases in these generative models.
There's a common internet example of asking, well, I think they've actually gotten better at this because they specifically have trained it for this example, but asking, you know, popular models, ChatGPT, Claude, Gemini, to generate an image of a full wine glass. And because there are very few images compared in the internet of a full wine glass versus a wine glass that's like half full, that for a long time these models just couldn't do it. They just weren't trained on generating an image of a full wine glass. So all of those edge cases are so important. Well, Carl, thank you very much for joining us. Carl's actually going to be back with us again for our next session, our final main session of the day. We've got a few more to go, but those will be a little bit more Brian and I speaking at you to recap. So Carl, thank you very much for joining us. Our next session is going to be a fun one. It's going to be an informal fireside roundtable, our second roundtable of the day, talking about the story behind Edge Impulse and any funny tales of building things behind the scenes. You should come and join us for that. So I'll see you then. Hello and welcome back for our second roundtable in quotation marks, more like a fireside chat here at the Imagine Innovators 2026 stream. If you've made it to this point and you've been watching from the beginning, I salute you. I know there's a couple of guys in the audience who have been doing that, interacting with us. We love to see it. This is going to be a kind of unscripted, off the hook roundtable discussion with some of the Edge Impulse R&D team. We've got Carl, who was in our session just before this. But for those who weren't watching that, Carl, what keeps you up at night when you're thinking about Edge Impulse? Maybe start with what you do first.
Data.
Bad data.
Before, right? Yeah, bad data, and just how can we make it easier for customers to spot these things? Because I think people just throw a load of data in sometimes, train a model and expect it to just work, right? And we need to add ways to stop them doing that and to point them in the right directions.
And then we're joined by Dan. Dan, what gives you nightmares at Edge Impulse?
Carl. I think just this idea, we have so much responsibility for what people are doing with our platform, and it's like people are building things and relying on us to help them build things that then go into real systems that affect people's lives in the real world. So that's what's exciting about it, but it's also what's kind of scary, because if we mess up, then it causes other people's stuff to get messed up, and at the end of the day it's not acceptable. So there's just a lot in terms of making sure we do a good job delivering quality, reliability, helping people understand things that are difficult to understand and aren't necessarily obvious.
I think what I'm hearing is that the saying, with great power comes great responsibility, is very applicable.
Exactly. I think it's sort of like the reason we created Edge Impulse in the first place was to give all developers the power that previously only a few people have. But the problem is that if you don't have that background and that understanding of the fundamentals, then you're much more reliant on the tools. And so that means we have to do a really good job of making sure we communicate things like, how well is your model performing in a way which you can understand and interpret.
Awesome. And then Brian, I suppose I can ask you the same thing. You've been with us here all day. What keeps you up at night aside from the Imagine Innovators?
Besides I was going to say the live stream. Yeah, jet lag, this live stream. I've got a pretty unique position where I get to experiment with a lot of the new tech and try things out without many repercussions, because I'm just building demos. I'm not the ones working with the end customers and going into production. So I wouldn't say a lot about Edge Impulse actually keeps me up at night. It's more I get to have fun and I get to play with the tools and I get to enjoy them, and then I give feedback to teams like the R&D team or the product team or the engineering team directly.
And Dan, how long have you been at Edge Impulse?
I was the first hire. I was the founding TinyML engineer was my job title, and that was like what was it, COVID year? 2020?
Yeah.
It's like, I've tried to forget, but it was early 2020 that I joined, like January or something like that.
And what about you? What about you, Carl?
I joined in January 22, I think. So like 4.5 years now. So.
And then, Brian?
I joined, February 2023.
Nice.
Yeah, so it's been a few years now too.
So Dan, I guess I'll start with you. Maybe in an abridged summary, can you tell me what the story's been from Edge Impulse? What was it like when you started? How has it evolved until now? Any bits and bobs in between?
Yeah, I mean, it's a long story. I guess it kind of starts for me here in Amsterdam in 2020. I think it was just before COVID as well, like the week before or something. But I had just joined the company and came to our launch party here, and we like made this demo where we had someone in a sheep costume doing like aerobics on stage or something like that, and I was just like, what on earth's going on? Who are these people? We're like a remote team, so it was my first time meeting Jan, who's our CTO, one of the founders. But it's just crazy, like when we were checking every day, like how many projects have been created, and there was like what felt like a torrent of people signing up for the platform, and then 6 years later, we have more than that probably every hour or something, and it's just like I was saying earlier, that like feeling of responsibility has gotten bigger and bigger because we have so many people depending on us, not just people who are like playing around and testing things out, but people who are building real livelihoods around their careers and products in Edge AI. I think that's what's really changed for me, is like the maturity of the technology and the use cases and applications. And at the beginning, it was still like no one had really heard of on-device AI. No one really knew what it was good for, and a lot of our job was educating people. A lot of us in the early company had a background in developer relations because of like needing to explain how this stuff works to people. And I guess that hasn't changed. We've still got that very strong DevRel DNA, but just like the way that we're working with customers now and the types of things that they're doing reflect the underlying reality, is that this is no longer an emerging technology. It has emerged, and we're sort of onto the next stage of how the technology is changing and transforming the way that people build stuff.
And in terms of growth and the number of users, when I started, it was fewer than 100,000. I remember, I think it was my first offsite. We were celebrating 100,000.
Yeah, in Portugal. Yeah, we had the 100,000 balloons.
Yeah, exactly. And it was like
opposite the hotel.
That was a massive number.
Yeah, we didn't literally have 100,000.
No, it's like, we had the balloons. There's one balloon and then a bunch of zero balloons.
We're not supposed to talk about offsites, but maybe we can sneak in a little bit. What's the story behind that?
That was just a celebration for hitting 100,000 users, because that is a significant milestone. When Dan started, he was looking at 2, 3, 4 users, right? So he's seen that growth. But in the time that I've been around, we've surpassed 300,000 now.
Wow!
So it's just been this massive growth, and that kind
almost 1 million projects as well now, right?
Yeah,
like 800,000 projects.
Like a million things people have done with the platform, and like even if it only took 1 minute. And they just poked out. That's still a lot of time.
Absolutely.
And then maybe I can go to you, Carl, here, or Dan. You can chip in. Maybe even Brian. Was there like a particular feature on the Edge Impulse platform that might not seem so obvious to the end user as being something that was very difficult to integrate, but from your side took a lot of work? What would be a good example of that?
Data inbox, because it's still not been integrated. No, I mean, there's always going to be teething problems everywhere. Like most of the things we've added, we've had to think about. Well, a lot of the research in ML, especially, is in PyTorch. So whenever we've brought new algorithms into the platform, we've had to translate them into TensorFlow or into JAX. So that's where a lot of the issues come, right? And a lot of the pain points is that nowadays with agentic stuff, they'd probably be much easier, but 2 or 3 years ago, those tools weren't around.
Do it manually.
Yeah, we had to do all that stuff manually.
It shot us to think about it right now, doing things manually.
Yeah, right. But literally, we'd have to take the arrays and make sure everything is step through the whole model, make sure that everything's exactly the same at each point with our test data. So yeah, that kind of stuff's been, I think, the hardest things to implement.
Yeah, I think these tool chain things. So I don't know if people who aren't aware, but like a lot of the like on-device sort of deployment tool chain is based in the TensorFlow ecosystem. So you've got like compilers that ship with some fancy silicon that runs models really fast, but it requires a TensorFlow model as input and stuff like that. So
just to interrupt, for anyone who's watching, what actually is TensorFlow?
It's basically a set of tools that were originally made by Google for defining and training deep learning models. So you kind of define the architecture of your model and how it's going to train, and there's very low level tools there and very high level tools, and then PyTorch is like the equivalent thing but from Meta, and there's some other ones as well. So there's a big ecosystem of different tools you use to define models, but there's like a subset of those that have been used more heavily for the on-device piece.
And so back to what we were talking about, every single time you ship a feature, it has to be integrated with TensorFlow. How much work is that?
It depends, sometimes it's easy. So there's all these tools that we've built or that we use that can convert automatically between formats and things like that. But every so often you get stuff that just doesn't really
just doesn't really
work
work.
as well.
Yeah.
And we have to go and do surgery on the models.
Yeah, and also if we want it to be like a first-class model in our platform, we want to be able to control things. If we've just taken a PyTorch model and then done the conversion, it's more difficult for us to control what's going on in the model. So that's why we've had to do things like re-implement things in TensorFlow rather than just using the PyTorch one.
So like the thing, you know, in the Edge Impulse, you can go to expert mode and view the source of the model and like change stuff. So like that all lives in TensorFlow world for us.
And so like some of the models you provide, like YOLO Pro, what was the story behind that? Why did you decide to make YOLO Pro? Obviously Ultralytics have their own YOLO models. What's the story behind that?
So we built it in TensorFlow because then like that's just the toolchain we use, right? So it just made more sense to work there because we know that when we convert the model from TensorFlow into TensorFlow Lite, it's going to work. Whereas there's sometimes issues with converting from an Onyx model, which is a type of model that's meant to be more platform independent, or from a PyTorch model directly into a TensorFlow model, into TF Lite model. There can be some issues there. So by building the model and training the model in the TensorFlow world, we know that which ops are going to work in the TensorFlow Lite model.
Maybe just something to elaborate there is that you said we built it in TensorFlow, making it sound like, hey, that was super easy.
Oh no, it wasn't super
but
easy.
this
Kudos
was
to Matt for the heavy lifting there. He did a huge thing.
Yeah, so another member of the research team, Matt Kelsey, he did a lot of work on that. It takes a long time. It's not just like, hey, I did this in a weekend. This was a big project for you guys.
So yeah, the idea behind YOLO Pro is that there's these famous YOLO models out there that are really good object detectors. It's just like a single shot object detector architecture, very popular, but a lot of the variants released by various different people over the years have either bad performance on int8, so when you quantize them, so you reduce the size of the precision of the weights from 32-bit floating point into 8-bit integers. Because of various quirks of the architectures, you'd lose a lot of the performance. So we wanted to come up with a version that quantizes better and works better when it's like really small, like a scaled down versions, and also one with a license that people who are developing commercially can use freely. There's a lot of the open source stuff is under a GPL or AGPL license, which basically means that if you created something with it, you would have to then open source that yourself, which is great for open source, but it's not great for someone who's trying to build something to solve their one-off industrial problem.
And we got a question from the audience actually, which is Edge Impulse at all looking into PyTorch to Executorch deployment to avoid conversion to TF Lite, or is that something that isn't sort of beneficial at the minute?
Yeah, so we're always sort of exploring these things and looking at the kind of trade-off and demand and what people want. And I think our long-term goal for the platform is like complete flexibility, so you can plug in whatever.
Like a kitchen sink of tools, basically.
Yeah, exactly. Like if you have an opinion about using one on-device inference framework or another, or whatever deployment mechanism, you can plug that in like a custom deploy block, for example. So we already do a lot of that for these different targets that we support that all have their own different compilers and runtimes and things like that. We don't have a first-party Executorch one, but there's no reason, and that would be kind of fun to see someone in the community do that. But also it's all just stuff that we play with and experiment with, and there's a lot of stuff that we do and try out that isn't necessarily shipped as a feature yet, because it takes so much testing. You know what I was saying before about what keeps me up at night? It's like, in order for us to sign off on something as being ready, it should be ready for like the most hardcore life or death use. And so we have huge amounts of tooling around automated testing for the TF Lite inference, for example. And we have all of these pipelines that we run when we're trying to upgrade that allow us to test the whole platform and make sure we have operator consistency and compatibility. This is something you just spent a long time trying to debug, is like a consistency between kernels.
Yeah, and I don't think we even found that.
No,
we didn't find the problem in the end.
You get these crazy rabbit holes. So by the time we release something, it's gone through so much fine-tooth comb kind of work. So that's why we err on the conservative side with some of these things, but also the platform is very extensible, so you can plug things in yourself.
And you go, right.
I was going to say, pulling on that thread a little bit, are there some examples of things you've worked on that haven't seen the light of day that you really were excited about but just didn't make it through that testing?
Yeah, good. I mean, there's so many things along the way.
Yeah.
I feel like research, it's like you got this thing that you've got a general direction you're trying to go in, and then to get there, you try all these different paths, and a lot of them along the way don't quite work out, and so like it's this like fuzzy road trying to get to things. There's also the constraints of like how much bandwidth we have in the engineering side of the company to take the stuff we built in research and put it into the product, and we have to be very selective there as well, because also once you build something and put it in the product, you're kind of making a contract with people like, hey, you can rely on this, we're going to keep it working, we're going to keep it up to date. So there's definitely been things that haven't reached that threshold yet where we've decided to fully support it. The data quality stuff you're working on is something that's been in the process for a long time. It's finally reached that point where I think we're going to be able to build some real like UX and tooling around it. But it's like, just, you know, we have this exploratory kind of remit where we're trying things out, and then sometimes we have to advocate for stuff within the product team, like, hey, we've realized this is really important, we've realized we can do this.
So there was a question that came in from the audience while you're speaking there, and it was saying, as a company, how do you decide how much time to spend on research and on what priorities? So maybe talk about the structure of Edge Impulse and the different teams and what your team does versus, say, the engineering team.
Yeah, cool. Like, we're very much an applied research team, so we do research where we're working on things that directly solve problems that we hear about from our customers. So that's one of the most important things. It's like we have this filter of, like, we're not just trying to push the boundaries of like learning theory or something like that. You know, that's very, very interesting stuff, but it's just not what our team happens to do. And so we judge it by that kind of filter. Then the next step is sort of prioritization and like risk. So we're thinking about like, how important is this? Is this like $1 million solution or $1 billion solution, or it's like a $50 solution? How many customers is it going to help? Is this going to help like a long tail of lots of different people, which is always good? Or is it something that's going to work well for like one customer that may not even be around a year from now? You know, we've had customers like go out of business or decide they want to do things in-house or something.
And to that point, was there something that maybe Carl, you can chime in as well, that you guys spent a lot of work developing on that you just ended up axing it in the end?
Yeah, there's been plenty of stuff like that. I mean, we did a bunch of NVIDIA Tower integration stuff for machine learning object detection models, and then NVIDIA deprecated those.
Oh, brilliant.
So that wasn't great. Then I did some work on we've got these pre-trained weights for YOLO Pro. I did some work on seeing whether we could do some logic hacking there to see if we can, if you're interested in one of the 500 classes in that model, you're just interested in one class from that, or several classes, is there a way that we can basically prune the pre-trained weights without doing any more training, so you don't need any data theoretically, to make a smaller model? That didn't really work. So
right.
The model,
well,
it worked. You could get a model that just had like 2 classes, but there was no latency improvement, and the model was basically the same size. So it was like we definitely have these ideas that then don't actually work in the end sometimes. And I mean, that's common in all research, right? Half of research just doesn't work. It doesn't see the light of day because nobody publishes negative results.
And on that note, you guys do a lot of cool work, and that's something the DevRel team and the research team is going to do now, is that I'm actually sitting in on your meetings, I'm in your Slack channel. We're going to try and communicate a lot of this work, even if it doesn't work out, and we can explain, here's some things we worked on, here's what's cool about it, here's what didn't work, and then maybe someone in the community picks it up or something like that. But basically, we want to give your team a lot more visibility and share that out to the world, because you do some really cool work.
Yeah, I'm excited for people to sort of see the inside story. And like some of these, you know, it's even helpful if people are hearing about stuff as we're developing it and give feedback, and then we can course correct or, you know, identify opportunities we might not have otherwise seen. That's another really cool thing actually about Edge Impulse, is that we have this huge community. So we have so much information coming from the community about what's important and where we should be focusing.
And so I've got a fun one. This could go for either of you, Carl or Dan, but have you seen any models that people have trained or use cases that people have made which are just completely unexpected? Or something that caught your eye and went, oh, I've never really thought about that before?
Not off the top of my head. I mean, I've seen a lot of bad data.
It's all about data for you.
Yeah, like for instance, like I mentioned in the previous one, like you've got someone's doing a nature camera and they're interested in animals like cows or whatever, and they've only labeled like 4 cows, but there's like 20 cows in the image. Like the model's never going to be able to work with that. Or other things like saw some dash cam footage once for like sleep detection or like drowsiness, but they'd augmented the data and they'd augmented they'd rotated it 90. It's like that camera is never going to have that kind of image. So that's the thing that I see somewhat often, is like, why this is never, it's not realistic, so you probably don't need it.
That's actually something that I found, the flipped images, that I realized that when I was training a model for household objects, and then I had the data augmentation fit the image, and I realized that an upside down sofa, it's not a sofa because it's upside down. The legs are not on top, right? Exactly. Same thing with like a lamp. The lamp shade was at the bottom, so it's not a lamp. And actually, once I disabled the option to flip the image, it performed better. One question we've got from the audience is, will Edge Impulse at some point provide a solution? So I'll give you some context. Edge Impulse is very well known for its support with computer vision now, especially with YOLO Pro. Is there going to be a similar solution for natural language processing beyond keyword spotting?
Yeah, good question. I mean, this is something that we've been talking about as well internally. I think it's not something we can like make any big judgment about right now on air, but it's like this whole context of physical agentic AI and then these on-device agentic models. The more general purpose the model, the more space it takes up, sort of as a drastic oversimplification. But like, if you want a model that can do everything, it has to be bigger. Whereas if you have a model which is more task specific, more task oriented, it can be smaller. And there's some really cool work that's been happening in the research community showing that you can train these task specific models for like on-device reasoning and things like that. Imagine it's for use in the context of like a car, like you're controlling all the entertainment and climate control inside a car. It doesn't need to know about ancient Roman history. So if you can fine-tune a model that is specifically suited to that, you can get away with a smaller one and be more energy efficient or have a less expensive processor. So I think there's an avenue there that it feels like something important to explore, but it's not something we've kind of committed to yet.
And completely different topic now. Going back to how much time you put into research, does Edge Impulse have like larger customers who you consider to be a bit more important and develop tools to support them, or is it more many similar sized customers?
It's kind of both. You know, we have this big diverse mix of customers. We care so much about individual developers as well. Like, it doesn't matter if you're like the CEO of a Fortune 500 company or if you're some random person on the internet. If you post in our forum, we're going to answer and help you. And that's been really important to us since the beginning. But then it is also really helpful to have this like understanding of a customer's like needs, and that sometimes comes more from the bigger customers because we have such a close engagement. You know, if somebody's like a free developer, then we're not really going to come to your house and like work to help you solve your problem. Whereas these bigger customers, you know, if you've got like a big industrial facility and you need our help figuring out how to solve problems there, we can literally send engineers on site and learn about exactly what you're trying to do, learn the ins and outs of the problem, get some of the domain knowledge, and that really informs what we do. So we obviously prioritize things that our customers need, but it's the very, very challenging job of our product team, with help from all the other teams, to try and balance, like, what are we building for the community, what are we building for big tier 1 customers, what are we building for the regular developers in the middle.
Very cool. Oh, sorry.
I was gonna ask you a different question, so maybe you had something to add.
Well, I had a question about someone made a comment in the chat saying, he was saying thank you for one of your responses, but he's like, I envy your jobs. So my question, like, I have an unconventional career path. I've been all over the place and landed at Edge Impulse. How does someone get into applied research for Edge AI? Like, you know, Carl, you had a different background as well. You were involved in biology. Dan, you were at Google. How does one get into a role like someone on your team? And either one of you can jump in.
Fun fact, we went to the same secondary school
What?
in the UK.
Yeah, we've known each other since we were 12, right?
Yeah.
Wow.
It's
Long
completely random, really, that we ended up working together.
Yeah.
But I mean, who wants to go first?
Wow, I mean, my career was via biology, and then I transitioned from biology to bioinformatics, which is basically data science for biology. But we've always been friends, and we were always chatting about what we'd be working on separately.
You introduced me to
I introduced to deep learning, yeah, which is a crazy thing. I was trying to train a image classification model to detect different cancers, blood cancers, and I started using Keras. And Dan was mentioning to me something about learning TensorFlow. And I was like, why are you bothering with TensorFlow? Just use Keras. Keras is basically a high-level version of TensorFlow, which makes it much easier to write the code for the models, whereas TensorFlow was much more low-level at that point. But then the story's a bit funny, because then Keras became part of TensorFlow, and Keras has now left again, so we won't get into that. But yeah, so like you say, I introduced it to deep learning. But then I started to push more towards the machine learning side of the biology stuff, and then an opening came in Dan's team, and so I just jumped to that.
So. Maybe Dan, what's your story?
Yeah, my story, I mean, it's a long, strange one, but I guess I was in teaching at the university I went to in the UK, Birmingham City University, for a couple of years after I graduated, and I was doing like auto ID technologies. This was like 2007, 2008. So this was sort of a precursor of a lot of this stuff. It's this category that includes like biometrics, face detection, face recognition, which at the time was not using machine learning, deep learning at all. It was using like computer vision and feature extraction. Then I there was like a whole detour where I wanted to go be a helicopter pilot in the military in the UK, dropped out of training after 2 weeks, and then moved to the US kind of randomly. And I ended up working at an AI company in Silicon Valley, in LA as a software engineer. And I wasn't doing AI stuff particularly. I was building developer tools to help our team build these conversational agents. And again, it was using old school symbolic AI, not deep learning stuff. I then thought like, oh wow, there seems to be this crazy stuff going on in Silicon Valley with all these new tech companies doing web stuff. That sounded really interesting, and I went to become a web engineer in Silicon Valley. The first company I worked at was Looped, which was Sam Altman's first company. So worked with him when it was like this little 30-person company.
Sam Altman, current CEO of OpenAI.
Yeah, so that's very, very random. Like he wasn't doing AI at the time either, and we both sort of went on this route. But I just got, we got, in that company, we got acquired by a bank, and then I was working on tooling, doing web engineering, and then I started working on tooling for the data science team, and then I started getting interested in data science and machine learning, and it was at the time where it was like big data, if that term is still even around very much, transitioning into the like deep learning revolution. So I started learning about machine learning models, then all this like crazy computer vision stuff came out, and then I got really interested, and so I ended up working at Google, and there's a whole load of stuff in between.
You missed the cricket farm.
Yeah, it's too long a story.
I was going to say there's a few more details in there
that's the rub of it. And then Brian, last but not least, how did you end up at Edge Impulse?
The short version, because I know we're running low on time, was I was in grad school and I came across a paper by Pete Warden about tiny ML and microcontrollers. Or was it he wrote TensorFlow Lite for microcontrollers.
Yeah.
So I was reading that paper and I reached out to him and he actually responded. I was like, hey, is anyone doing this work? And he's like, not really in Canada, not really in the US, but go check out Edge Impulse. So I checked out the website. I was like, this is the company I need to be at. Reached out to the person who was doing our HR at the time. And there was no position, but I was like, hey, I want to be here. Just let me know when there is one. And about a month later, she reached out to me and interviewed. And here we are 3 years later.
So what my understanding is that everyone who works at Edge Impulse doesn't have a conventional story of how they ended up at Edge Impulse.
Seems to be that way, yeah. A lot of detours in our backgrounds.
Yeah. But I guess that's how you create such a colourful culture at the company.
Yeah, and I think it's pretty common in, like, especially this era of machine learning and deep learning. Like, a lot of us started our career before it was even a thing, particularly. You know, people were obviously doing this stuff for a long, long time, but it came into the public eye like during our careers. So, and then I think there's like a lot of people who have gone to school specifically for that since, and then now everything's got turned on its head because suddenly like massive scale pre-training of language models has become like the super important thing, which again, no one was expecting overnight. So I think the moral of the story is if you're interested in something, just sort of go for it and you'll find your way there. And if you don't know what you're interested in particularly, just like keep trying stuff and you'll find stuff.
Awesome. Carl, Dan, and obviously Brian, thank you very much for this little informal chat about everything that goes behind Edge Impulse. That wraps up with our final main session of the day. All we have left now is a recap, but make sure you join us for the recap because we're going to have one of the co-founders of Edge Impulse joining us. Jan, he's sort of chilling in the background doing a little dance.
You're in for a treat.
Come us back. Join us in 10 minutes. We're also going to be announcing giveaways and doing a recap of the entire day. So, see you in 10 minutes. we've come to the end of our Imagine Innovators 2026 live stream. The only thing we have left to do is to have a little recap of the day with myself and Brian, but we have a very special guest with us here, Jan from Edge Impulse. Jan, what do you do at Edge Impulse?
Yeah, that's a good question. I used to do everything. I co-founded Edge Impulse in 2019 together with Zach Shelby. These days I run the whole group, so I try to do as little as possible and sit in many meetings. But yeah, I still have passion for product and engineering mostly. So,
and so, I mean, you've watched Edge Impulse go from, we had Dan here a second ago telling us how, Edge Impulse has grown across the years. But from your point of view, how has Edge Impulse really shaped from when you co-founded it to where we are now?
Yeah, so it's weird, right? If you start something, you literally start from a blank canvas. And I typed Git init into my code editor, and that's how we kicked this thing off. And I just wanted to build the tool that I felt was missing myself. I really believed that I could use machine learning to build better and better devices. That's where it came from. I didn't think about building this huge community yet, or building a big company even. I just wanted to have tools to my disposal to use sensor data to build, in the end, better control loops and better devices. And then you blink your eyes twice, we're 7 years later, and it's just astonishing, right? The community, 300,000 plus, number of projects, 750,000 plus, over 2,000 papers that actually cite Edge Impulse, which is great because I never finished my bachelor's. So if someone is watching the live stream, I would love an honorary doctorate.
Back to the unconventional path of Edge Impulse.
There we go. There's millions, tens, hundreds of millions of devices that have some Edge Impulse in it, and we're discovering more every day, and even in the sessions today, it's all kinds of use cases, things people are building that I never even knew of. It just happens.
Because even in the few years I've been here, the growth has been crazy.
It is, and you can see it goes faster and faster and faster every year, and it's super encouraging to see that.
So let's talk a little bit about the physical Imagine Innovators event. For us, Brian and I, we've mainly been holed up in this
We've been locked in a room away from...
giving you a live stream, a snapshot of some of those talks. But from your side, how did you feel Imagine Innovators has gone?
Yeah, really cool. I mean, the whole ecosystem is maturing, right? And I think for a long time, for kind of the first couple of years, the community has really been talking about, okay, I have a little sensor data, and look, I can build a model, right? Because that is already really, really cool. 10 years ago, there was no machine learning. We had to invent all of these principal components and stack them together to get that working. But AI is now everywhere, and this whole concept of a computer helping you, build better algorithms is sort of commonplace. The whole community has matured, and now people start thinking about, okay, systems, how do I monitor these things? What if I deploy these at scale? How does that look like? Can I actually apply this to other fields? I think robotics is really close to IoT. It's sensor data, but except for perception models, you build decision models on top of it. And now we see these two worlds collide. And I think that's really cool. I said it this morning, we're going from models to systems. But you see that in every single talk here at the conference. People are really building complete systems.
And so, what are some things that you think people should catch up on after the show?
So, I thought it was really interesting. In a couple of talks, sensor fusion came back. And I still think that is a really, really, really powerful construct that we're slowly building our sensor fusion capabilities out. We've had sensor fusion on sort of low data rate samples before, like accelerometer plus gyroscope. That's something you can do. But people have woken up to the idea that you can now do multimodal things, right? One model can operate on multiple sensor modalities. And we've seen a first sort of converge on vision plus language in vision language models. But it's also waking people up. It's like, hey, can we actually train a model on image plus audio plus sensor data into a same model and perceive the world from multiple angles at the same time? For me, this is right. We're building it to the platform now. But I've seen people that build sort of on top of Edge Impulse already this multimodal perception layer. So that's really cool, and that sort of strengthens my idea that once we add that to the platform, it's going to be really useful for a lot of people.
And we talked about that earlier, is the extensibility of Edge Impulse and building on top of it. But when things become useful to a lot of people, well, then we incorporate it into the platform.
Yeah, and I think that's always been the foundation sort of behind what we do. Like if you think about sort of the four things, like I think of Edge Impulse as four things, right? There's the data component, there's the DSP and pre-processing component that's sort of overlooked by every other ML platform, but you know that's the world we come from. Then there's the machine learning component and the deployment component. And every customer is probably good at one of these things already. If you're working with a wearable health manufacturer, they're probably already good at the DSP part. If you're working with an AI engineer, they're probably already good at the ML part, but not at the DSP and the data part. If you're working with an embedded person, they might already be good at the deployment part. So the pluggability of, you need to plug your knowledge and the tools, etc., that you already have in at any of those phases, but still be able to use the complete breadth of the tool for everything that you don't have. That's been key, like since the start. Our first customer was Aura, the maker of the sleep ring, right? They had tremendous DSP capabilities.
Oh, so I didn't know that. So Aura, the maker of the
first
ring,
customer,
was your
November,
first Edge
November
Impulse. Wow, okay, and those
I think that was a good one.
One of our producers is probably wearing one at the minute, actually.
Yeah,
so what would you say that this event says about the future direction of Edge AI? Where do you think Edge AI is going in the next few years?
I think it's going to expand, right? So if I'm looking at, like, we've really thought about sort of Edge AI in the concept of IoT devices so far. Now we have compute that is getting faster, so we're starting to get LLMs and VLMs on device, which means that you don't need to train certain models. You can do zero shot for a lot of stuff. That expands the possibilities. Robotics looks very close to IoT, to my mind, so I'd love to go there. Then we have XR, so wearable glasses. That is also starts to look like IoT. So I think we're gonna like broaden the scope of everything that we do. And for me, that is all sort of Edge AI. And like if you see how far we've gotten in 7 years, like 7 years ago, just the ability that you could run a little classifier that detects gestures was really cool. When Dan saw that, he jumped his job from Google and went to work for Edge Impulse instead because we made it usable. And now we're getting to a state where I can run a vision language model just on an IQ9.
That's what I was going to say. We had the Ventuno Q in earlier and talking about that.
Amazing.
Reachy Mini, like that's some growth.
That is in 7 years.
Yeah.
Right. And this is the worst that it will ever be. Today. Right. So if you're looking at like all of these models, the capabilities, everything you can do on device, this is the worst it will ever be. Think about where we're going to be in 7 years. It's
mind-blowing.
Astonishing. Yeah.
For those of you who could not attend Imagine Innovators in person, we tried to give you a really wide gamut of all the sessions, but naturally there were sessions that we weren't able to cover. Some of these was the Edge Impulse Power User Roundtable, how Edge AI is transforming robotics, or is it the other way around? An ocean water quality classification for bacteria contaminate. Oh, it's a very wordy title. Ocean water quality classification for bacteria contamination using TinyML and sensor fusion, and navigating maritime VHF comms using LLMs and Edge Impulse. So that's a snapshot into some of the sessions we couldn't cover today. It's incentive to attend some more of Edge Impulse's events. So maybe tell me, are there events that you're going to have scheduled in the future? How can I get involved?
I knew you were going to ask me this question, and unfortunately, I don't know what webinars that we have coming up.
June 10th with OnLogic, I just heard.
June 10th with OnLogic.
So on the ipXchange side, one thing that we do is host webinars, and we're doing a webinar with OnLogic, Edge Impulse, and someone else, but OnLogic and Edge Impulse. Mainly, if you want to tune into that, we have a link in the chat that's going to be about integrating small language models and for, I think, vision applications.
And then beyond that, to stay up to date, check out edgeimpulse.com, all of our socials, LinkedIn. We post all of our events there. ipXchange, we're partnering with them quite a bit now, so check out their socials as well. You'll stay informed.
Awesome. And then, Brian, I'm going to get your opinion. What do you think from your side has been your favorite demo that we've seen today?
My favorite demo today, I think, was actually the session with Mark. Even though building the app didn't work out at all, it
was worth a shot. Yeah.
It was worth a shot, and I think it's just the subject matter, looking into agentic AI and how we can support our developers' workflow with agentic AI and agent skills, and looking down that path. That's personally interesting to me. And then, of course, session with Jim playing Doom. That's kind of fun. And there was a whole bunch of other conversations that were great and I enjoyed. So
I think the Roundtable one that we just had, basically doing a bit of a dive into what goes on behind the Edge Impulse team.
I enjoyed that. I was watching the time and I was like, we're going to run out of time. I want to speak for an hour at this Roundtable. So we might have to do another one with those guys and bring another session back, do a webinar or something with them.
For those of you in the audience, if you have any more burning questions to ask us, now is the time to get them in. Otherwise, I would say, what do you think has been, I'll start with you, Jan, the main takeaway for our audience to remember from Imagine Innovators?
Oh man, you should have prepped me.
Wow.
So, if you look at, if you're building any device today, I think the developments in AI are going so fast that I think it's good to just take a breather, go toy around with some of the new stuff that's coming out, right? I mean, I think I'm very biased against agentic coding, for example. So to confirm my biases, I've tried to write some of that recently. I think there's a huge amount of like new insights, efforts, things that the speakers at Imagine Innovators have taken today. So hopefully that's some inspiration to go, toy around with some new stuff, step out of your comfort zone for a change. Go play with multimodal data or with the robotic stack that people have presented, or some of the agentic tools, or if you've never done like proper integration of a VLM into your tool chain, go play with that for change and try to shape your try to play around with tools before having your opinion ready. There's so much cool stuff happening in the world right now. It's basically impossible to keep up to date. So go try and go play.
And then maybe Brian, from your side, what do you think the key takeaway for our audience is?
And I was prepped for this question, but I'm rethinking it now after hearing Jan speak. But I think what I want people to take away is the community. Like Jan said a lot of things, but ultimately the way you stay up to date and you stay informed is coming to events like this, talking to people, getting to know a new developer. And we wouldn't be here with any of you without any of you guys. Like 300,000 plus users, that's crazy. So the only reason we can do events like this is because of the community and people showing up, exchanging information, being excited about things. So I hope people on the live stream feel like they were included, they're a part of the community, tried to interact with a lot of your questions, answer them on the fly. I know there's some we didn't get to. And then I hope you guys learned something from that. So something that inspired you to try a new tool, just like Jan was talking about. What did you see today where you're like, oh, I need to play with that. I didn't know I could do that. So find one thing that you want to experiment with and then talk to someone else in the community about it.
Awesome. One thing that we've mentioned a few times throughout this live stream today is that we're giving away some Arduino Uno Qs. If you'd like to be a part of that, we've put a Luma link in YouTube chat to sign up. Go check that out if you'd like to win one for yourself. We've already talked about how you can get started with Edge Impulse. If you want to find out more about them, go check out their website, go get in contact with them. Jan's doing a little bit of a dance. If you want to find out, if you want to find out more disruptive technology with Edge Impulse, but also with other companies, and just keep up to date with what's going on in this current crazy world, Edge AI, physical AI, connectivity, everything embedded IoT. That's where we come in, ipXchange, as I mentioned right at the start. We're a content platform by engineers for engineers. We do a lot of videos. That's, you know, sometimes live streams like this, but also technical tutorials, webinars. So go check that out. Lastly, I have to give some thanks. So obviously the immediate thanks is to Edge Impulse. Thank you very much for having us here, for letting us into your event, for hosting this live stream. I want to give thanks to Jan and all of the speakers that we've had in the Clock Tower studio today, in particular those who've run demos, Mark in particular, who tried to code a project live. That was quite impressive. We want to give thanks to Arduino, Foundries.io, Qualcomm, and all of the supporting partners of Imagine Innovators 2026. And last and most definitely not least, we have to give thanks to you in the audience. Thank you very much for joining us. I hope that you've learned something useful from this session today.